The fourth dynasty of Egypt's Old Kingdom represents one of the most remarkable periods of centralized power and architectural achievement in human history. Spanning approximately 120 years from 2613 to 2494 BC, this dynasty witnessed an unprecedented concentration of resources, labor, and technological innovation that would culminate in the construction of the Giza Pyramid complex. The political landscape during this era was characterized by absolute royal authority, sophisticated administrative systems, and a level of social organization that enabled pharaohs to mobilize tens of thousands of workers for decades-long construction projects. The foundation for such massive undertakings was established through a carefully orchestrated system of provincial governance, where regional administrators, known as nomarchs, served as direct representatives of pharaonic authority. These officials oversaw the collection of taxes in the form of grain, livestock, and labor obligations, creating a steady flow of resources toward the royal capital at Memphis. The Fourth Dynasty pharaohs had perfected the art of resource extraction from Egypt's agricultural heartland, with the annual Nile flood cycle providing the predictable surplus necessary to support large-scale construction projects during the inundation season when agricultural work was impossible. The political climate of this period was marked by internal stability and minimal external threats, allowing the royal court to focus entirely on monumental building projects rather than military campaigns. Unlike later periods of Egyptian history, the Fourth Dynasty faced no significant invasions from neighbouring peoples, and the unified kingdom stretched from the First Cataract in the south to the Mediterranean coast in the north. This territorial security provided the pharaohs with uninterrupted access to Egypt's natural resources, including the limestone quarries of Tura, the granite quarries of Aswan, and the vast agricultural output of the Nile Delta and Upper Egyptian provinces. Khufu, known to the Greeks as Cheops, ascended to the throne around 2589 BC and immediately began planning what would become the largest pyramid ever constructed. Historical records from this period, though fragmentary, suggest that Khufu ruled for approximately 23 years, dedicating virtually his entire reign to the construction of his pyramid complex. Contemporary inscriptions found in the pyramid's internal chambers, discovered during 19th century explorations, bear Khufu's cartouche and provide definitive evidence of his association with the Great Pyramid. These hieroglyphic markings, painted in red ochre by the ancient construction crews, include references to work gangs with names like Friends of Khufu and Drunkards of Menkaure, revealing the organised labour system that built these monuments. The scale of Khufu's project required unprecedented logistical coordination. Modern calculations suggest that the Great Pyramid contains approximately 2.3 million stone blocks, each weighing between 2.5 and 15 tons, with some granite blocks in the King's Chamber weighing up to 80 tons. The precision of the construction is remarkable, with the base of the pyramid deviating from perfect squareness by only 2.3 centimetres across its 230-metre width. This level of accuracy required sophisticated surveying techniques and mathematical knowledge that demonstrates the advanced state of Egyptian engineering during Khufu's reign. Khafre, who succeeded to the throne around 2558 BC, continued the Giza building tradition with his pyramid complex, which includes the famous Great Sphinx. Archaeological evidence suggests that Khafre ruled for approximately 26 years, during which time he not only completed his own pyramid, but also oversaw the carving of the Sphinx from a natural limestone outcrop left behind by his father's quarrying operations. The Sphinx, measuring 73 metres in length and 20 metres in height, represents one of the largest single stone sculptures ever created and bears facial features that many scholars believe resemble those found on statues of Khafre. The second pyramid at Giza appears larger than Khufu's when viewed from certain angles due to its construction on slightly higher ground and its steeper angle of inclination. However, it actually contains less stone and represents a more efficient use of resources compared to its predecessor. This suggests that by Khufu's reign, Egyptian architects had refined their construction techniques and developed methods to achieve maximum visual impact while reducing material requirements. The pyramid's internal chamber system is notably simpler than that of the Great Pyramid, featuring only 2 main chambers connected by a descending passage that extends below ground level. Menkaure, the third pharaoh associated with Giza, ruled from approximately 2532 to 2503 BC and constructed the smallest of the 3 main pyramids. Standing at just 65 metres in height compared to the 146-metre original height of the Great Pyramid, Menkaure's monument reflects either a decline in available resources or a conscious decision to prioritise quality over size. The lower portion of this pyramid was originally cased in red granite rather than the white limestone used for its predecessors, creating a striking visual contrast that would have been immediately apparent to ancient observers. The religious significance of pyramid construction in ancient Egyptian society cannot be understood without examining the complex theological concepts surrounding divine kingship and the afterlife. The pharaoh was considered the living embodiment of Horus, the falcon-headed god, and upon death was believed to join with Ra, the sun god, in his daily journey across the sky. The pyramids served as both tomb and resurrection machine, designed to facilitate the pharaoh's transformation from mortal ruler to divine being capable of ensuring Egypt's continued prosperity. The pyramid texts, first appearing in the Pyramid of Unas during the 5th dynasty, provide detailed insights into the religious beliefs that motivated these massive construction projects. These hieroglyphic inscriptions describe the pharaoh's journey through the underworld, his battles against the forces of chaos, and his ultimate rebirth as a star in the northern sky. While the Giza pyramids predate these written texts, archaeological evidence suggests that the same fundamental beliefs about royal divinity and cosmic resurrection were already well established during the 4th dynasty. The orientation of the Giza pyramids reflects sophisticated astronomical knowledge and religious symbolism. Each pyramid is aligned with cardinal directions to within a fraction of a degree, with the Great Pyramid's alignment being accurate to within 3/60ths of a degree. The internal passages of these structures are oriented towards specific stars and constellations that held religious significance, including the circumpolar stars that the Egyptians associated with eternal life because they never disappeared below the horizon. The construction of these monuments required not only religious motivation, but also practical innovations in engineering, logistics, and workforce management. Recent archaeological discoveries at Giza have revealed the remains of workers' villages, complete with bakeries, breweries, and medical facilities, suggesting that the pyramid builders were well-fed, permanent employees rather than slaves, as often depicted in popular culture. Analysis of skeletal remains from these worker cemeteries shows evidence of heavy labour, but also of medical care, including healed fractures and surgical interventions. The archaeological timeline of Giza excavations spans over 2 millennia, beginning with ancient tomb robbers who penetrated the pyramid's internal chambers within centuries of their construction. Medieval Arab historians, including al-Makrizi in the 15th century, recorded detailed accounts of pyramid exploration and the discovery of various artifacts. The modern scientific investigation of Giza began in earnest during Napoleon's Egyptian campaign of 1798 to 1801, when French scholars conducted the first systematic measurements and documentation of the pyramid complex. The 19th century witnessed increasingly sophisticated archaeological techniques applied to Giza, beginning with Giovanni Battista Caviglia's excavations of the Sphinx in 1816, and continuing through Auguste Mariette's establishment of the Egyptian Antiquities Service in 1858. The British archaeologist Flinders Petrie conducted meticulous surveys of the Great Pyramid between 1880 and 1882, producing measurements accurate to within millimetres that remain valuable to researchers today. His work established many of the fundamental dimensions and architectural features that continue to puzzle and fascinate scholars. The 20th century brought new technologies and methodologies to Giza archaeology, including aerial photography, ground-penetrating radar, and computer modelling. The Harvard University Boston Museum of Fine Arts expedition, led by George Reisner from 1905 to 1947, systematically excavated the mastaba tombs surrounding the pyramids and uncovered crucial evidence about the organisation of the royal court and the administrative systems that supported pyramid construction. More recent investigations have employed cosmic ray meography, thermal imaging, and 3D laser scanning to reveal previously unknown chambers and passages within the pyramid structures. The technological achievements required to construct the Giza pyramids represent perhaps the most sophisticated engineering project undertaken in the ancient world, involving the precise coordination of quarrying operations, transportation systems, and lifting mechanisms that moved millions of stone blocks across distances of hundreds of kilometres. The quarrying process alone demanded an understanding of geological formations, stone fracture patterns, and extraction techniques that allowed Egyptian workers to remove massive limestone blocks from the Mokattam Formation cliffs east of Giza with remarkable consistency in size and quality. Archaeological investigations at the Tura limestone quarries, located approximately 13 kilometres south of Giza on the east bank of the Nile, have revealed extensive underground galleries where ancient workers extracted the fine white limestone used for the pyramid's outer casing. These subterranean chambers, some extending over 100 metres into the cliff face, show clear evidence of systematic extraction methods involving copper tools, wooden wedges, and controlled fracturing techniques. Workers would first score the limestone surface with copper chisels to create precise cutting lines, then drive wooden wedges into natural fissures or deliberately created slots. When water was applied to the wedges, their expansion would split the stone along predetermined planes, allowing for the removal of blocks with relatively smooth surfaces, requiring minimal finishing work. The granite quarrying operations at Aswan, nearly 900 kilometres south of Giza, presented far greater technical challenges due to the extreme hardness of the stone and the massive size of individual blocks required for the pyramid's internal chambers. The famous unfinished obelisk at Aswan, abandoned in antiquity due to natural cracks in the stone, provides crucial insights into ancient granite extraction methods. Workers would pound the granite surface with dolerite hammers weighing up to 5.5 kilograms, gradually pulverizing the stone to create trenches around the desired block. This process required extraordinary patience and precision, as a single granite block destined for the king's chamber would require months of continuous labour by teams of specialised quarrymen, working in shifts to maintain the necessary rhythm and force. Transportation of these massive stone blocks from quarries to the construction site involved sophisticated logistical planning and innovative engineering solutions that maximised the efficiency of Egypt's natural transportation network. During the annual Nile flood season, which typically lasted from July to October, specially constructed barges could navigate channels that brought them within a few hundred metres of the Giza Plateau. Recent archaeological discoveries have identified harbour installations and canal systems that connected the Nile to the pyramid construction site, including a major harbour complex discovered by French archaeologist Pierre Tallet that could accommodate vessels carrying blocks weighing up to 80 tons. The barges themselves represented remarkable feats of naval architecture, constructed from cedar wood imported from Lebanon and designed with reinforced hulls capable of supporting massive stone loads without structural failure. Papyrus documents discovered at Wadi al-Jarf, dating to Khufu's reign, describe the organisation of boat crews responsible for transporting limestone blocks from Tura to Giza. These administrative records detail the names of boat captains, crew sizes and delivery schedules that reveal a highly organised maritime transportation system operating with military-like precision and efficiency. Overland transportation from the harbour to the pyramid construction site required the development of sophisticated road systems and mechanical advantage devices that could move blocks weighing several tons across sandy terrain. Experimental archaeology conducted by Mark Lerner and other researchers has demonstrated that teams of 20 to 30 workers could drag 2.5-ton limestone blocks across wooden rollers or specially prepared roadways using rope harnesses and coordinated pulling techniques. The roadways themselves were constructed with carefully graded limestone chips and gypsum mortar, creating smooth surfaces that reduced friction and prevented the wheels or rollers from becoming mired in sand. The most technically challenging aspect of pyramid construction involved lifting these massive blocks to heights exceeding 140 meters above ground level, requiring engineering solutions that pushed the limits of ancient technology and human organization. While no definitive evidence exists for the specific lifting methods employed at Giza, archaeological analysis of the pyramid's construction features and contemporary Egyptian technology suggests several possible approaches, each requiring sophisticated understanding of mechanical principles and structural engineering. The ramp theory, supported by numerous Egyptologists including Dieter Arnold and Mark Lerner, proposes that builders constructed temporary earthen and stone ramps that spiraled around the pyramid's exterior or approached from one side at gradually increasing angles. Physical evidence for such ramps includes limestone blocks with drag marks and rope abrasions found embedded in the pyramid structure, suggesting they were incorporated into the monument as construction progressed. Computer modelling has demonstrated that straight ramps approaching the pyramid from the east would require massive quantities of fill material and would extend over 1 kilometre in length to maintain workable gradients for dragging heavy blocks. Alternative lifting theories include the use of lever systems and counterweight mechanisms that could raise blocks in stages using wooden scaffolding and bronze or copper mechanical components. The discovery of copper tools and fittings within the pyramid's internal chambers suggests that Egyptian engineers possessed sophisticated metalworking capabilities and understood principles of mechanical advantage that would be necessary for such systems. Experimental reconstructions have shown that combinations of levers, fulcrums and inclined planes could enable relatively small teams of workers to raise multi-ton blocks through vertical distances of several meters. The internal chamber systems of the Great Pyramid represent perhaps the most sophisticated architectural achievement of the entire complex, featuring a network of passages, galleries and chambers that demonstrate advanced understanding of structural engineering, ventilation systems and astronomical alignments. The Grand Gallery, measuring 47 meters in length and rising at a 26-degree angle, showcases corbelled construction techniques that distribute the enormous weight of the overlying masonry across a series of precisely cut granite and limestone blocks. Each corbel projects slightly beyond the one below it, creating a gradually narrowing ceiling that culminates in a flat capstone spanning the remaining gap. The precision of the Grand Gallery's construction becomes apparent when examining the fitting of individual blocks, which were cut and positioned with tolerances measured in millimeters rather than centimeters. The side walls feature a series of rectangular slots and raised platforms whose purpose remains debated among scholars, but which clearly demonstrate the builder's intention to create a functionally complex space rather than a simple passageway. The gallery's acoustic properties have been studied extensively, revealing that its dimensions create specific resonance frequencies that may have held religious or practical significance for ancient Egyptian rituals. The King's Chamber, constructed entirely from red granite transported from Aswan, measures 10.47 meters long, 5.23 meters wide, and 5.81 meters high, with walls composed of precisely fitted blocks weighing up to 80 tons each. The chamber's roof consists of 9 massive granite beams, each spanning the chamber's width and supporting 5 additional layers of granite blocks, designed to distribute the weight of the overlying masonry. This construction technique, known as a relieving chamber system, demonstrates sophisticated understanding of structural loads and stress distribution that prevented the collapse of the chamber under the enormous pressures created by hundreds of thousands of tons of stone above. The Queen's Chamber, despite its traditional name, likely served a different ritual function related to the pharaoh's afterlife journey, rather than housing a royal burial. Located at the end of a horizontal passage extending from the Grand Gallery's lower entrance, this chamber features a corbelled ceiling and walls of finely dressed limestone that create an acoustically resonant space. The chamber's eastern wall contains a niche whose precise purpose remains unknown, but which may have held a statue or ritual object related to the pharaoh's resurrection ceremonies. The precision of the Great Pyramid's orientation and measurements reflects astronomical knowledge and surveying techniques that achieved accuracy levels remarkable for any pre-modern civilization. The pyramid's base alignment with the cardinal directions deviates by only 3 arc minutes and 38 arc seconds from true north, an accuracy that requires sophisticated understanding of stellar observation and mathematical calculation. This alignment was likely achieved through careful observation of circumpolar stars, particularly those in the constellation that Egyptians called the Bull's Thigh, and which modern astronomers know as the Big Dipper. The pyramid's internal passages align with specific astronomical phenomena that held religious significance for ancient Egyptians. The descending passage points toward the star Alpha Draconis, which served as the pole star during the 4th dynasty, while the ascending passage and Grand Gallery align with the southern culmination of the constellation Orion, which Egyptians associated with Osiris, god of the dead and resurrection. These alignments required precise calculation of stellar positions and sophisticated understanding of the relationship between terrestrial construction and celestial mechanics. The workforce organisation required for pyramid construction involved logistical coordination on a scale unprecedented in the ancient world, with recent archaeological evidence suggesting that between 10,000 and 20,000 workers were permanently employed at Giza during peak construction periods. The discovery of workers' villages south and east of the pyramid complex has revealed the infrastructure necessary to support this massive labour force, including residential quarters, administrative buildings, food production facilities, and medical treatment centres that provided comprehensive care for the construction crews. The workers' cemetery, excavated by Zehi Hawass and Mark Lehner, contains over 600 burials that provide detailed insights into the lives, working conditions, and social organisation of the pyramid builders. Skeletal analysis reveals evidence of heavy physical labour, including enlarged muscle attachment points, joint degeneration, and healed fractures consistent with construction work. However, the burials also show evidence of medical care, adequate nutrition, and respectful treatment that contradicts popular misconceptions about slave labour and suggests instead a well-organised workforce of skilled professionals and seasonal labourers. The administrative papyri discovered at Wadi al-Jarf provide unprecedented documentation of the workforce organisation systems that supported pyramid construction. These records, dating to the final years of Khufu's reign, detail the organisation of work gangs with names like Drunkards of Menkaura and Friends of Khufu, each consisting of approximately 200 workers divided into smaller crews of 10 to 20 individuals responsible for specific tasks. The papyri record work assignments, food rations, tool distributions and transportation schedules that reveal a bureaucratic system of remarkable sophistication and efficiency. The mathematical precision embedded within the Great Pyramid's dimensions has captivated scholars and researchers for centuries, revealing relationships that suggest the ancient Egyptian builders possessed mathematical knowledge far more sophisticated than previously understood. When Giovanni Battista Caviglia first measured the pyramid's base perimeter in 1816, he discovered that the ratio of the perimeter to the height approximated 2p, a relationship that would later be refined through increasingly precise measurements. Flinders Petrie's meticulous 1880 to 1882 survey established the pyramid's base length at 230.38 metres and its original height at 146.59 metres, creating a perimeter-to-height ratio of 6.2857, remarkably close to 2p. This mathematical relationship becomes even more intriguing when examining the pyramid's slope angle of 51 degrees, 52 minutes and 14 seconds. This specific angle creates a situation where each triangular face has a slope height that relates to the base in a ratio approximating phi, the golden ratio of 1.618. The discovery of this relationship led mathematician John Ligon to propose that Egyptian architects deliberately incorporated both pi and phi into their design, though whether this represents conscious mathematical planning or coincidental dimensional relationships remains fiercely debated among Egyptologists and mathematicians. The internal dimensions of the Great Pyramid reveal additional mathematical relationships that extend beyond simple geometric coincidences. The King's Chamber measures 20 royal cubits in length, 10 royal cubits in width, and 11.18 royal cubits in height, creating proportions that relate to the square root of 5 and other irrational numbers. The royal cubit itself, measuring approximately 52.36 centimetres, appears to have been derived from astronomical observations and human proportions in ways that naturally generated these mathematical relationships without requiring abstract theoretical knowledge of pi or phi. Recent analysis by architect and researcher John Anthony West has identified additional mathematical patterns within the pyramid's construction, including relationships between chamber volumes, passage angles, and overall structural proportions that suggest a unified geometric system governing the entire design. The Grand Gallery's length of 47 metres corresponds to precisely 90 royal cubits, while its height progression follows mathematical sequences that relate to both the pyramid's external dimensions and the positions of internal chambers. These relationships extend to the pyramid's missing capstone, whose theoretical dimensions would complete mathematical progressions evident throughout the structure. The pyramid's internal passage system demonstrates sophisticated understanding of both structural engineering and astronomical observation, with each major passageway serving multiple functions related to construction logistics, religious symbolism, and celestial alignment. The descending passage, carved directly into the bedrock beneath the pyramid, maintains a consistent downward angle of 26 degrees, 18 minutes, and 9.7 seconds for a distance of 105 metres before reaching the subterranean chamber. This passage required precise surveying techniques to maintain its exact trajectory through solid limestone, demonstrating the builder's ability to project geometric lines through three-dimensional space with extraordinary accuracy. The ascending passage, which branches from the descending passage approximately 18 metres from the pyramid's entrance, rises at the same 26-degree angle but in the opposite direction, creating a mirror-image relationship that may have held symbolic significance related to the pharaoh's journey between the underworld and celestial realms. This passage measures 1.2 metres in height and 1.04 metres in width, dimensions that required workers to crawl or crouch while moving through it, suggesting that access to the upper chambers was deliberately restricted and ceremonially significant. The so-called air shafts extending from both the king's and queen's chambers represent one of the most enigmatic features of the pyramid's internal architecture, with their precise astronomical alignments suggesting purposes far beyond simple ventilation. The southern shaft from the king's chamber maintains a consistent upward angle of 45 degrees and 14 minutes, pointing toward the constellation Orion during the 4th dynasty period. The northern shaft from the same chamber angles upward at 32 degrees and 28 minutes, aligning with Alpha Draconis, the pole star of Khufu's era. These shafts required extraordinary precision in their construction, as they had to maintain exact angles while passing through the pyramid's internal structure without intersecting other passages or chambers. The southern shaft from the King's Chamber extends for approximately 65 meters before reaching the pyramid's exterior surface, requiring the builders to calculate its trajectory through multiple courses of masonry while accounting for the pyramid's sloping sides. The shaft's internal dimensions of 20.5 by 22.5 centimeters remained consistent throughout its length, demonstrating sophisticated understanding of three-dimensional geometry and construction planning. The Queen's Chamber shafts present even greater mysteries, as they do not extend completely through the pyramid structure, but terminate within the masonry after travelling approximately 65 meters from the chamber. Robot explorations conducted by Rudolf Gantenbrink in 1993 and subsequent investigations have revealed that these shafts contain several turns and obstacles, including stone blocks with copper fittings that may have served as symbolic doors or actual mechanical devices. The southern shaft from the Queen's Chamber aligns with Sirius, the star associated with the goddess Isis, while the northern shaft points towards the circumpolar stars associated with eternal life. The acoustic properties discovered within the pyramid's chambers have revealed additional layers of complexity that suggest the builders understood sound propagation and resonance in ways that enhance the monument's ritual functions. The King's Chamber exhibits resonance frequencies around 110 Hz when subjected to acoustic testing, a frequency that corresponds to the fundamental resonance of the chamber's granite construction and creates standing wave patterns that would amplify human voices or musical instruments used during ancient ceremonies. Research conducted by acoustic engineer John Stuart Reid has demonstrated that the King's Chamber's dimensions create specific harmonic relationships that would enhance the acoustic properties of ancient Egyptian religious chants and ritual music. The chamber's proportions generate resonance nodes at positions corresponding to the sarcophagus location and the chamber's geometric centre, suggesting that the builders deliberately designed the space to create optimal acoustic conditions for ceremonial activities. The granite construction material contributes to these acoustic properties, as granite's crystalline structure reflects sound waves differently than limestone, creating unique reverberations and harmonic overtones. The Grand Gallery functions as an acoustic amplification chamber, whose corbelled construction and precise dimensions create resonance effects that would carry sound from the lower passages to the King's Chamber above. Experimental acoustic testing has revealed that sounds generated at the gallery's lower end undergo specific frequency modifications as they travel upward, with certain frequencies being amplified while others are dampened. The gallery's side niches and raised platforms may have served as acoustic baffles or resonance chambers that fine-tuned these sound transmission properties. The missing capstone, known as a pyramidion, represents one of the most significant losses in understanding the Great Pyramid's original appearance and symbolic meaning. Historical accounts suggest that the pyramid was completed with a capstone made of polished granite, electrum, or possibly pure gold, creating a brilliant apex that would catch and reflect sunlight across the Giza Plateau. The capstone's absence, likely removed during antiquity for its precious metal content, eliminates crucial evidence about the pyramid's original height, final construction techniques, and symbolic completion. Mathematical analysis of the pyramid's current truncated summit indicates that the original capstone measured approximately 1.57 meters square at its base and rose to a height of roughly 1 meter above the pyramid's current flat top. This capstone would have completed the pyramid's geometric form while adding symbolic elements related to the Benben stone, the primordial mound from which ancient Egyptians believed creation began. The capstone's 4 triangular faces would have been inscribed with hieroglyphic texts and religious symbols that proclaimed the pharaoh's divine nature and eternal rule. Surviving pyramidions from other Egyptian pyramids provide insights into the Great Pyramid's missing capstone, including examples made from black granite, limestone, and precious metals that feature carved solar discs, falcon imagery, and hieroglyphic inscriptions praising the deceased pharaoh. The pyramidion from the Pyramid of Amenemhat III at Dashur, carved from black granite and inscribed with eyes of Horus and solar symbolism, demonstrates the sophisticated artistry and religious significance invested in these apex stones. Similar decorative and symbolic elements would have adorned Khufu's capstone, creating a focal point that unified the pyramid's architectural and religious functions. The symbolic meaning of the missing capstone extends beyond its physical presence to encompass fundamental concepts of ancient Egyptian cosmology and royal ideology. The capstone represented the pharaoh's transformation from earthly ruler to solar deity, with its elevated position symbolizing the king's ascension to join Ra in his daily journey across the sky. The capstone's reflective surface would have created a beacon visible from great distances, serving as a constant reminder of the pharaoh's divine presence and continued protection of Egypt even after death. Archaeological evidence from the pyramid's summit area suggests that the capstone's removal occurred during the medieval period, possibly during the systematic dismantling of the pyramid's outer casing stones for use in Cairo's construction projects. Arab historians, including al-Makrizi, recorded that the pyramid's apex was already missing during the 15th century, though earlier accounts suggest it may have survived into the Islamic period. The precise method of the capstone's removal remains unknown, though its extraction would have required sophisticated lifting equipment and considerable effort given its estimated weight of several tons. The pyramid's current flat summit, measuring approximately 10 meters square, provides a platform from which researchers have conducted detailed studies of the monument's construction techniques and original appearance. Examination of the uppermost courses of masonry reveals construction details invisible from ground level, including tool marks, fitting techniques, and evidence of the methods used to position the final blocks before the capstone's installation. These observations have contributed to understanding the final phases of pyramid construction and the technical challenges involved in completing such massive monuments with precision and symbolic appropriateness. The astronomical alignments embedded within the Giza pyramid complex represent one of the most compelling aspects of ancient Egyptian architectural achievement, revealing sophisticated understanding of celestial mechanics that extended far beyond practical construction requirements. Robert Bauval's Orion correlation theory, first proposed in his 1994 work The Orion Mystery, fundamentally transformed scholarly understanding of the pyramid's positioning by demonstrating that the three main pyramids at Giza mirror the arrangement of the three belt stars in the constellation Orion with remarkable precision. This correlation extends beyond simple positional matching to encompass the relative brightness and size relationships between the stars and their corresponding pyramids. Bauval's analysis revealed that the Great Pyramid of Khufu corresponds to Al-Nitak, the brightest and easternmost star in Orion's belt, while Khafre's pyramid aligns with Al-Nilam, the central star, and Menkaura's smaller pyramid matches Mintaka, the westernmost and dimmest star of the trio. The ground plan positioning of these monuments recreates the celestial arrangement with extraordinary accuracy, including the slight offset of Menkaura's pyramid from the perfect diagonal alignment formed by its two larger companions. This offset precisely mirrors Mintaka's position relative to the other belt stars, suggesting deliberate astronomical planning rather than coincidental positioning. The temporal aspect of Bauval's theory adds another layer of complexity to the astronomical interpretation. Using computer modelling to reconstruct ancient skies, Bauval determined that around 10,500 BC, the Orion constellation would have appeared at its lowest point in its precessional cycle, positioned directly above the southern horizon at the moment of heliacal rising. This date corresponds to the mythological first time, or Zep Tepi, mentioned in Egyptian religious texts, when the gods were believed to have ruled Egypt directly before transferring power to human pharaohs. While this temporal correlation remains controversial among mainstream Egyptologists, it demonstrates the sophisticated astronomical knowledge required to conceive such long-term celestial relationships. The precision of the Orion correlation becomes even more remarkable when examining the specific angles and distances involved in the pyramid positioning. The angle formed by drawing lines from the Great Pyramid to the other two pyramids measures approximately 38 degrees, matching the angle of Orion's belt as it appeared in ancient Egyptian skies. The distance ratios between the pyramids also correspond to the apparent brightness ratios of their stellar counterparts, with the spacing between Khufu's and Khafre's pyramids being proportionally similar to the visual separation between Al-Nitak and Al-Nilam as observed from Earth. Archaeological evidence supporting the Orion correlation includes the discovery of model boats buried near the Great Pyramid, positioned to point toward the constellation's rising position. These cedar vessels, measuring over 40 meters in length, were likely intended to transport the deceased pharaoh through the celestial waters to join Orion in the afterlife. The boat's orientation and positioning relative to the pyramid's eastern face creates direct sightlines toward the constellation's heliacal rising point, reinforcing the connection between terrestrial monument and celestial destination. The cardinal direction alignments of the Giza pyramids demonstrate surveying accuracy that approaches modern engineering standards, requiring astronomical observation techniques of extraordinary sophistication. The Great Pyramid's orientation deviates from true north by only 3 arc minutes and 38 arc seconds, an accuracy level that could only be achieved through careful observation of circumpolar stars over extended periods. Ancient Egyptian surveyors likely used the stretching of the cord ceremony, a ritual process that involved tracking the movement of specific stars throughout the night to establish precise north-south baselines. The surveying methodology employed at Giza required understanding of stellar motion, precession effects, and the relationship between celestial observations and terrestrial measurements. Egyptian astronomers would have observed the transit of circumpolar stars across vertical reference lines, noting the precise moments when stars reach their highest and lowest positions during their nightly rotation around the celestial pole. By bisecting the angle between these extreme positions, surveyors could establish true north with remarkable precision, despite the absence of a bright pole star during the 4th Dynasty period. The pyramid's internal passage alignments reveal additional layers of astronomical sophistication that extend the monument's celestial connections beyond simple cardinal orientation. The descending passage maintains its 26-degree downward angle to point directly at Alpha Draconis, which served as the pole star around 2600 BC. This alignment required precise calculation of the star's position relative to the celestial pole, as Alpha Draconis was never a perfect pole star, but rather circled the true celestial pole at a distance of approximately 3 degrees. The ascending passage and grand gallery system creates an upward-angled sightline that targets the southern culmination of Orion, specifically the moment when the constellation reaches its highest point in the southern sky. This alignment holds particular significance in Egyptian religious beliefs, as the southern sky was associated with the afterlife realm, where deceased pharaohs joined the imperishable stars. The 26-degree upward angle of these passages corresponds precisely to the altitude of Orion's belt stars during their southern culmination as viewed from Giza's latitude. The so-called air shafts extending from the king's and queen's chambers represent perhaps the most precisely targeted astronomical alignments within the entire pyramid structure. The southern shaft from the king's chamber points directly toward Orion's belt at an angle of 45 degrees and 14 minutes, while the northern shaft targets the circumpolar region at 32 degrees and 28 minutes. These angles were calculated to account for the pyramid's internal geometry while maintaining exact stellar alignments, requiring sophisticated three-dimensional planning that coordinated architectural requirements with astronomical precision. The Queen's chamber shafts demonstrate even more complex astronomical targeting, with the southern shaft aligning with Sirius, the brightest star in the night sky and one of paramount importance in Egyptian religious thought. Sirius, known to the Egyptians as Sopdet and associated with the goddess Isis, mark the beginning of the annual flood cycle when it rose heliacally just before dawn in mid-July. The shaft's alignment with this crucial star connects the pyramid's internal architecture to the fundamental rhythm of Egyptian agricultural and religious life. The northern shaft from the Queen's Chamber points toward the circumpolar stars that Egyptians called the indestructible ones, stars that never set below the horizon and therefore symbolized eternal life. This alignment specifically targets the area around Kochab and Firkad in the constellation Ursa Minor, stars that would have been prominent in the northern sky during the 4th dynasty. The shaft's precise angle of 39 degrees and 30 minutes required careful calculation to account for the chamber's position within the pyramid, while maintaining the desired stellar alignment. Recent investigations using robotic exploration have revealed that the Queen's Chamber shafts contain several mysterious features that may relate to their astronomical functions. The discovery of small copper fittings and stone blocks within these passages suggests they may have contained mechanical devices or symbolic doors that could be opened during specific astronomical events. The copper elements, including pins and plates discovered by Rudolf Gantenbrink's robot explorations, show signs of deliberate placement and may have served as sighting devices or ritual implements related to stellar observation ceremonies. The seasonal astronomical phenomena that influence pyramid design extend beyond simple stellar alignments to encompass complex relationships between solar, lunar, and stellar cycles that governed ancient Egyptian religious and agricultural practices. The pyramid's eastern face receives the first rays of sunlight at dawn throughout the year, with the monument's geometry creating specific shadow patterns that mark important calendar dates. During the spring and autumn equinoxes, the pyramid's shadow disappears completely at noon, creating a dramatic visual effect that ancient observers would have interpreted as divine manifestation. The relationship between the pyramid's dimensions and the Earth's orbital mechanics reveals additional astronomical connections that suggest the builders possessed sophisticated understanding of planetary motion. The pyramid's base perimeter of 921.45 metres, when divided by its height of 146.59 metres, produces a ratio that closely approximates the relationship between the Earth's polar and equatorial radii. This dimensional relationship implies knowledge of the Earth's oblate spheroid shape, information that would require extensive astronomical observation and mathematical calculation to derive. Precession-related phenomena played crucial roles in the pyramid's astronomical design, with the monument's alignments accounting for the slow wobble of Earth's axis that causes stellar positions to shift over millennia. The precision of the Orion correlation required understanding that stellar alignments would change over time, with the constellation's position relative to the horizon undergoing systematic variation over the 26,000-year precessional cycle. The pyramid's designers appear to have calculated these long-term changes, positioning the monument to maintain optimal stellar relationships across extended time periods. The integration of multiple astronomical cycles within the pyramid's design demonstrates sophisticated understanding of celestial mechanics that coordinated solar, stellar, and precessional phenomena into a unified architectural system. The monument's various alignments target different astronomical events occurring at different timescales, from daily solar motion to annual stellar cycles to millennial precessional changes. This multi-layered astronomical programming suggests that the pyramid served as a kind of three-dimensional astronomical instrument, encoding celestial knowledge in permanent architectural form. The discovery of additional astronomical alignments within the broader Giza complex has expanded understanding of the site's celestial connections beyond the three main pyramids. The causeway connecting Khafra's pyramid to his valley temple aligns with the summer solstice sunrise, creating a direct line of sight from the pyramid to the eastern horizon at the year's longest day. The Sphinx, carved from natural bedrock and oriented due east, serves as an astronomical marker for equinoctial sunrises, while its leonine form connects to stellar symbolism associated with the constellation Leo. The Great Sphinx of Giza stands as perhaps the most enigmatic monument of the ancient world, its massive leonine body and human head carved from a single outcrop of limestone that rises from the desert floor like a geological anomaly frozen in time. Measuring 73 metres in length, 20 metres in height and 19 metres in width, this colossal sculpture represents the largest monolithic statue ever created, its sheer scale dwarfing even the most ambitious sculptural projects of later civilizations. The monument's traditional attribution to Khafre during the 4th dynasty places its construction around 2558 to 2532 BC, making it contemporaneous with the second pyramid at Giza and integrating it into the broader architectural program that transformed the plateau into ancient Egypt's most sacred royal necropolis. Archaeological evidence supporting Khafre's association with the Sphinx includes the discovery of inscriptions and statuary fragments within the nearby Valley Temple that bear his cartouche and distinctive facial features. The Valley Temple, connected to Khafre's pyramid by a causeway that runs directly past the Sphinx's southern flank, contains multiple diorite statues of the pharaoh that display facial characteristics remarkably similar to those carved on the Sphinx's weathered visage. The temple's precise astronomical alignment with the Sphinx and its integration into the pyramid complex's overall design suggest coordinated planning that unified these monuments into a single ceremonial landscape. The Sphinx's construction methodology reveals sophisticated understanding of geological formations and stone carving techniques that maximize the potential of the natural limestone outcrop while creating a monument of unprecedented artistic and symbolic complexity. The bedrock from which the Sphinx was carved consists of alternating layers of hard and soft limestone belonging to the Mokattam Formation, geological strata that created both opportunities and challenges for the ancient sculptors. The harder limestone layers, particularly those forming the Sphinx's head and upper body, provided durable material capable of supporting fine detail work, while the softer layers required careful management to prevent structural instability during the carving process. The quarrying activities associated with Khufu's pyramid construction created the geological conditions that made the Sphinx's creation possible, leaving behind a large knoll of bedrock that rose approximately 20 metres above the surrounding quarry floor. This natural formation provided the raw material for the Sphinx, while its elevated position created the dramatic visual impact that ancient observers would have found religiously and aesthetically compelling. The decision to transform this quarry remnant into a colossal sculpture demonstrates the 4th dynasty architect's ability to integrate practical construction requirements with monumental artistic vision. The carving process itself required coordinated efforts by teams of skilled sculptors working with copper chisels, wooden mallets, and abrasive stones to gradually shape the massive limestone outcrop into its final form. Evidence of ancient tool marks remains visible on the Sphinx's surface, particularly in areas where later restoration work has not obscured the original carving techniques. These tool marks reveal that the sculptors worked systematically from top to bottom, removing limestone in controlled layers while constantly adjusting their approach to accommodate variations in stone hardness and natural fracture patterns. The Sphinx's leonine body demonstrates sophisticated understanding of animal anatomy and sculptural proportion that created a convincing representation of feline musculature and posture, despite the constraints imposed by the original bedrock formation. The powerful haunches, extended forelegs, and alert posture convey a sense of controlled strength and vigilant guardianship that perfectly suited the monument's protective function within the pyramid complex. The transition from human head to lion body required careful planning to maintain anatomical credibility, while preserving the symbolic meaning inherent in this hybrid form. However, geological evidence discovered during the 20th century has raised significant questions about the traditional dating of the Sphinx, with some researchers proposing construction dates thousands of years earlier than the 4th dynasty. Robert Schoch, a geologist from Boston University, conducted detailed analysis of the Sphinx's weathering patterns during the 1990s and identified erosion characteristics that he argues result from prolonged exposure to heavy rainfall, rather than wind-driven sand abrasion. Schoch's findings suggest that the Sphinx's body shows clear evidence of water erosion in the form of vertical channels and undulating surfaces that could only have been created by centuries of intense precipitation. The geological argument centers on the fact that the Sahara region experienced its last major humid period between approximately 10,000 and 5,000 BC, when regular monsoon rains created a much wetter climate than existed during the 4th dynasty. Schoch argues that the deep vertical erosion channels visible on the Sphinx's body and the surrounding enclosure walls could only have been formed during this earlier humid period, suggesting that the monument was carved when the climate was capable of producing the heavy rainfall necessary to create such dramatic weathering patterns. Schoch's analysis identified distinct differences between the erosion patterns visible on the Sphinx and those found on other monuments at Giza that are definitively dated to the 4th dynasty. The limestone mastaba tombs surrounding the pyramids, carved from the same Mokattam Formation limestone as the Sphinx, display weathering characteristics consistent with 4,500 years of exposure to wind-blown sand and occasional light rainfall. These tombs show primarily horizontal erosion layers and surface pitting that contrasts sharply with the vertical channeling and deep undulations observed on the Sphinx's flanks. The enclosure walls surrounding the Sphinx provide additional geological evidence for Schoch's water erosion theory, displaying weathering patterns that extend deep into the bedrock and create undulating surfaces characteristic of prolonged water exposure. These walls, carved from the same limestone strata as the Sphinx itself, show consistent erosion patterns that suggest simultaneous exposure to the same weathering processes. The depth and consistency of this erosion, according to Schoch's analysis, would require thousands of years of regular rainfall to develop, far exceeding the limited precipitation that has occurred in the region since the 4th dynasty. Critics of Schoch's geological interpretation, including geologist James Harrell and Egyptologist Mark Lehner, have proposed alternative explanations for the observed weathering patterns that maintain the traditional 4th dynasty dating. Harrell argues that the vertical erosion channels result from the natural jointing and fracturing patterns inherent in the Mokattam Formation limestone, combined with periodic flooding events and groundwater seepage that could produce similar weathering effects over shorter time periods. These critics point out that limestone formations naturally develop vertical fractures that channel water flow and concentrate erosion along specific pathways. The debate over the Sphinx's weathering patterns has been complicated by extensive restoration work conducted throughout ancient and modern times that has obscured much of the original surface detail. Ancient Egyptian restoration efforts, documented in inscriptions dating to the 18th dynasty, involve the application of limestone blocks and mortar to repair damage caused by natural weathering and human interference. These repairs make it difficult to distinguish between original carved surfaces and later restoration work, complicating efforts to analyse the monument's geological history. Modern restoration projects, beginning with extensive work conducted by the Egyptian Antiquities Organization in the 1980s and 1990s, have further altered the Sphinx's surface characteristics by applying new limestone blocks, chemical consolidants, and protective coatings designed to prevent further deterioration. While these interventions were necessary to preserve the monument, they have created additional challenges for researchers attempting to study the original weathering patterns and determine the monument's construction date through geological analysis. The Sphinx's missing nose represents one of the most visible examples of damage sustained by the monument throughout its long history, with the destruction of this prominent facial feature creating a gap that fundamentally alters the sculpture's appearance and symbolic impact. The nose, which would have projected approximately 1.5 meters from the face when intact, was carved from the same limestone as the rest of the head, and would have required careful structural planning to ensure its stability, given the forces of wind, thermal expansion, and gravitational stress acting upon it. Historical accounts of the nose's destruction vary considerably, with some sources attributing the damage to Napoleon's artillery during the French campaign in Egypt, while others point to earlier Islamic iconoclastic activities or natural weathering processes. The most reliable historical evidence suggests that the nose was already missing by the 15th century, as Arab historian al-Makrizi made no mention of it in his detailed descriptions of the Sphinx, written around 1400 AD. Earlier accounts by Arab geographers, including al-Idrisi in the 12th century, also fail to describe the nose, suggesting its destruction occurred before the medieval period. Archaeological investigation of the area around the Sphinx's base has failed to recover fragments of the missing nose, despite extensive excavation work that has uncovered numerous other architectural elements and sculptural details. The absence of nose fragments suggests either that the limestone pieces were removed from the site after the destruction occurred, or that the nose was deliberately destroyed and the fragments disposed of elsewhere. The clean break patterns visible on the face indicate that the destruction was likely sudden and complete, rather than gradual weathering over time. The Sphinx's ceremonial beard, carved as a separate element and attached to the chin area, represents another significant loss that has altered the monument's original appearance and symbolic meaning. Fragments of this beard were discovered during excavation work conducted by Emile Barrès between 1925 and 1936, revealing that the beard was constructed from multiple limestone blocks fitted together and secured to the main sculpture with metal clamps and mortar joints. The recovered fragments, now displayed in the British Museum and the Egyptian Museum in Cairo, show detailed carving work that includes the traditional braided pattern associated with divine and royal beards in Egyptian art. The beard's construction as a separate architectural element suggests that it was added to the Sphinx after the initial carving was completed, possibly as part of a later restoration or modification project. The attachment methodology, involving metal clamps and precisely cut joints, demonstrates sophisticated stoneworking techniques that required careful planning and execution to ensure structural stability. The beard's eventual collapse appears to have resulted from the failure of these attachment systems rather than weathering of the beard itself. Ancient restoration efforts documented in hieroglyphic inscriptions reveal that the Sphinx required regular maintenance throughout Egyptian history, with major restoration projects recorded during the reigns of Thutmose IV, Amenhotep II, and Ramesses II. The famous dream stela, erected by Thutmose IV between the Sphinx's paws, describes how the prince cleared away sand that had accumulated around the monument and conducted repairs to ensure its continued preservation. This inscription provides crucial evidence that the Sphinx was already considered ancient and sacred by the 18th dynasty, approximately 1,000 years after its presumed construction during the 4th dynasty. The symbolic significance of the Sphinx within ancient Egyptian religious and political ideology extends far beyond its role as a guardian monument, encompassing complex theological concepts related to royal divinity, solar worship, and the pharaoh's relationship with cosmic forces. The combination of human head and lion body created a powerful visual metaphor for the pharaoh's dual nature as both human ruler and divine being, with the lion form representing royal strength and courage, while the human features proclaim the king's intelligence and wisdom. This hybrid imagery became a standard element of Egyptian royal iconography, appearing on countless sculptures, reliefs, and decorative objects throughout Egyptian history. The Sphinx's eastward orientation toward the rising sun connected it directly to solar worship practices that formed the foundation of Egyptian religious thought during the Old Kingdom period. Each dawn, the monument would be illuminated by the first rays of sunlight, creating a dramatic visual effect that ancient observers would have interpreted as divine manifestation. The Sphinx's position relative to Khufu's pyramid and valley temple created sightlines that incorporated the monument into sunrise ceremonies and other solar rituals performed by the royal court and priesthood. The leonine symbolism embedded in the Sphinx's form carried specific religious and political meanings that reinforced pharaonic authority and divine legitimacy. Lions were associated with the sun god Ra in his aspect as the fierce defender of cosmic order, while the constellation Leo held astronomical significance related to the flooding of the Nile and the renewal of agricultural fertility. The Sphinx's massive scale and permanent positioning at Giza proclaimed the pharaoh's eternal vigilance and protective power, serving as a constant reminder of royal authority even after the king's death and transformation into a divine being. The monument's integration into the broader Giza complex created symbolic relationships that connected earthly kingship with cosmic order and divine protection. The Sphinx's positioning between the pyramids and the Nile Valley placed it at the threshold between the realm of the living and the sacred space of royal burial, making it a guardian figure that controlled access to the most holy areas of the necropolis. This liminal position reinforced the Sphinx's role as mediator between human and divine realms, embodying the pharaoh's unique status as the bridge connecting mortal subjects with eternal gods. The emergence of alternative historical theories proposing advanced pre-Egyptian civilizations has fundamentally challenged conventional archaeological understanding of pyramid construction, with proponents arguing that the technical sophistication evident at Giza exceeds the documented capabilities of 4th dynasty Egypt. These theories typically center on the premise that an earlier, technologically advanced civilization either directly built the pyramids or provided the knowledge and techniques necessary for their construction, with this hypothetical culture subsequently disappearing from the historical record through cataclysmic events or gradual decline. The most prominent advocate for advanced pre-Egyptian civilization theories has been Graham Hancock, whose extensive research into ancient monuments worldwide has led him to propose the existence of a sophisticated maritime civilization that flourished during the last ice age and possessed advanced knowledge of astronomy, mathematics, and engineering. Hancock's analysis of the Giza complex focuses on the precision of astronomical alignments, the mathematical relationships embedded in pyramid dimensions, and construction techniques that he argues represent capabilities far beyond those attributed to ancient Egyptian civilization by mainstream archaeology. Hancock's interpretation draws heavily on the geological evidence presented by Robert Schoch regarding the Sphinx's water erosion patterns, extending this analysis to propose that the entire Giza complex originated during the humid period between 12,000 and 8,000 years ago. According to this theory, the original monuments were constructed by survivors of Atlantis, or a similar advanced civilization who possessed sophisticated knowledge of geology, astronomy, and construction engineering that enabled them to create structures of unprecedented precision and durability. The 4th dynasty. Egyptians, in this interpretation, merely restored and modified existing monuments rather than creating them from scratch. The Atlantean influence hypothesis specifically suggests that refugees from Plato's lost civilization brought advanced technological knowledge to Egypt following the destruction of their homeland around 11,600 years ago. Proponents of this theory point to similarities between Plato's description of Atlantean architecture and the construction techniques evident at Giza, including the use of massive stone blocks, precise astronomical alignments, and sophisticated drainage systems. They argue that the sudden appearance of advanced pyramid construction techniques during the 4th dynasty, without clear developmental precedents in earlier Egyptian architecture, supports the idea of external technological transfer from a more advanced civilization. Archaeological evidence cited in support of Atlantean influence includes the discovery of anomalous artifacts and construction techniques that appear inconsistent with conventional understanding of 4th Dynasty capabilities. These include the precise fitting of massive granite blocks in the King's Chamber, the sophisticated internal passage systems with their exact astronomical alignments, and the mathematical relationships embedded in pyramid dimensions that suggest knowledge of advanced geometric principles. Proponents argue that these features represent technological achievements that required centuries or millennia of development, far exceeding the time frame available during Khufu's 23-year reign. The lost technology hypothesis proposes that ancient Egyptians possess scientific and engineering knowledge that has been subsequently lost to history, enabling them to accomplish construction feats that appear impossible using the tools and techniques documented in archaeological records. This theory attempts to reconcile the evident sophistication of pyramid construction with the 4th Dynasty dating by proposing that Egyptian civilization achieved technological capabilities that were later forgotten due to political upheavals, natural disasters, or deliberate suppression by religious authorities. Christopher Dunn's analysis of precision machining marks found on granite surfaces within the Great Pyramid has provided some of the most compelling evidence for the lost technology hypothesis. Dunn, a precision machinist with extensive experience in modern manufacturing, has identified tool marks on granite surfaces that he argues could only have been created using high-speed rotary equipment with diamond-tipped cutting tools. His examination of the granite sarcophagus in the King's Chamber revealed saw marks with feed rates that would require machinery operating at speeds impossible to achieve with copper tools and manual labour. The granite drilling evidence presents particularly challenging questions for conventional archaeological interpretation, with core samples removed from granite blocks showing spiral grooves and feed rates that appear to exceed the capabilities of ancient Egyptian tools. Dunn's analysis of these drilling patterns indicates cutting speeds and pressure applications that would require powered machinery rather than manual drilling techniques. The precision of these cuts, combined with their consistency across multiple granite elements, suggests systematic use of advanced cutting technology rather than exceptional craftsmanship using primitive tools. Acoustic engineering theories have emerged as another component of the lost technology hypothesis, with researchers proposing that the pyramid's internal chambers were designed to harness and manipulate sound frequencies for practical or ceremonial purposes. John Stuart Reid's acoustic analysis of the King's Chamber has revealed resonance properties that could amplify human voices or musical instruments to extraordinary levels, creating sound effects that ancient observers might have interpreted as supernatural phenomena. The chamber's granite construction and precise dimensions appear specifically designed to create these acoustic effects, suggesting deliberate engineering rather than coincidental properties. The acoustic properties extend beyond simple amplification to include frequency-specific resonance effects that could have been used for communication, healing, or religious ceremonies. Reid's research has demonstrated that the King's Chamber exhibits resonance frequencies that correspond to human vocal ranges and ancient Egyptian musical scales, creating harmonic relationships that would enhance the effectiveness of chanted prayers or ritual music. The chamber's granite construction contributes unique acoustic characteristics that differ significantly from limestone chambers, suggesting deliberate material selection for acoustic purposes. Power generation theories represent perhaps the most controversial aspect of the lost technology hypothesis, with some researchers proposing that the Great Pyramid functioned as a massive energy device rather than simply a tomb. These theories typically focus on the pyramid's internal structure, particularly the Grand Gallery and King's Chamber, as components of a sophisticated machine designed to harness Earth's natural electromagnetic fields or convert mechanical energy into electrical power. While such theories lack archaeological support, they attempt to explain the pyramid's complex internal architecture through functional rather than purely ceremonial interpretations. The electromagnetic properties of the pyramid's construction materials have attracted attention from researchers investigating possible technological functions beyond burial purposes. The limestone and granite used in pyramid construction exhibit different electrical conductivity properties that could theoretically create electromagnetic effects under specific conditions. Some researchers have proposed that the pyramid's internal structure, with its combination of conductive and insulating materials, could function as a massive capacitor or electromagnetic resonator, designed to accumulate and discharge electrical energy. Diffusionist theories proposing global connections between pyramid-building cultures in Egypt, Mesoamerica, and other regions have gained support from researchers who identify striking similarities in construction techniques, astronomical alignments, and architectural forms across geographically separated civilizations. These theories challenge the conventional archaeological assumption that pyramid construction developed independently in different regions, instead proposing that knowledge transfer occurred through maritime contact, migration, or inheritance from a common ancestral civilization. The architectural similarities between Egyptian and Mesoamerican pyramids include the use of massive stone blocks, precise astronomical alignments, and complex internal chamber systems that suggest shared technological knowledge or cultural exchange. The Pyramid of the Sun at Teotihuacan, for example, exhibits base dimensions that closely approximate those of the Great Pyramid when adjusted for different measurement systems, while its astronomical alignments target similar celestial phenomena. These similarities extend beyond coincidental resemblance to encompass specific technical solutions to construction challenges that suggest direct knowledge transfer. Maritime contact theories propose that ancient civilizations possessed navigational capabilities and seafaring technology sufficient to enable transoceanic voyages thousands of years before Columbus. Evidence supporting these theories includes the discovery of cocaine and tobacco residues in Egyptian mummies, substances that were only available in the New World, and the presence of apparently Caucasoid and Negroid features in Olmec sculptures from Mesoamerica. While mainstream archaeology remains skeptical of pre-Columbian transoceanic contact, these findings suggest the possibility of cultural exchange that could explain architectural similarities between geographically separated pyramid-building cultures. The global distribution of pyramid construction across multiple continents and time periods presents challenges for theories of independent development, particularly when examining the technical sophistication required for such monuments. Pyramids appear in Egypt, Mesopotamia, Mesoamerica, Peru, China, and Southeast Asia, often exhibiting similar construction techniques and astronomical alignments despite the geographical distances and temporal separations involved. The consistency of these architectural solutions across diverse cultures suggests either remarkable convergent evolution or some form of cultural transmission that facilitated knowledge sharing. Astronomical alignment patterns found in pyramid complexes worldwide show striking similarities that extend beyond simple solar or cardinal direction orientations to encompass complex relationships with specific stars and constellations. The Angkor Wat complex in Cambodia, for example, exhibits astronomical alignments that mirror those found at Giza, including orientations toward the constellation Draco and precise cardinal direction alignments that require sophisticated surveying techniques. These similarities suggest shared astronomical knowledge that transcends regional cultural boundaries. Archaeological evidence supporting diffusionist theories includes the discovery of similar construction techniques across geographically separated sites, including the use of precisely fitted megalithic blocks, sophisticated drainage systems, and complex internal chamber arrangements. The Sacsayhuaman fortress in Peru exhibits stone-fitting precision that rivals the Great Pyramid's construction, with massive blocks weighing hundreds of tons fitted together without mortar, using techniques that remain poorly understood. The similarity of these construction methods to those employed at Giza suggests either independent development of identical solutions or knowledge transfer through cultural contact. The timeline challenges posed by diffusionist theories require reconsideration of conventional chronologies that place pyramid construction in different regions at widely separated time periods. Recent archaeological discoveries have pushed back the dates of some pyramid construction, particularly in South America, where sites like Corral in Peru have been dated to approximately 2600 BC, making them contemporaneous with early Egyptian pyramid construction. These revised chronologies reduce the temporal gaps between pyramid-building cultures and make cultural exchange more plausible. Genetic studies of ancient populations have provided additional evidence for prehistoric migration and cultural contact that could explain architectural similarities between distant civilizations. DNA analysis of ancient remains from various pyramid-building cultures has revealed unexpected genetic connections that suggest population movements and cultural exchange occurring thousands of years before previously documented contact. These genetic links provide potential mechanisms for the transmission of architectural and astronomical knowledge across vast geographical distances. The scholarly consensus regarding ancient Egyptian civilization development maintains that pyramid construction represents the culmination of centuries of gradual technological and social evolution within Egypt itself, without requiring external influence or lost advanced civilizations. Mainstream Egyptology points to clear developmental sequences in Egyptian architecture, from mastaba tombs through step pyramids to the true pyramids of the 4th dynasty, demonstrating continuous innovation and refinement of construction techniques over several centuries. Archaeological evidence supporting conventional chronology includes extensive documentation of Egyptian cultural development through pottery sequences, artistic styles, and hieroglyphic writing systems that show continuous evolution from pre-dynastic periods through the Old Kingdom. The discovery of workers' villages, administrative papyri, and construction tools at Giza provides direct evidence for the organization and methods used in pyramid construction, demonstrating that 4th dynasty Egyptians possessed the knowledge, resources, and social organization necessary for these projects without requiring external assistance. The technological capabilities documented for 4th dynasty Egypt include sophisticated mathematics, astronomy, engineering, and organizational systems that adequately explain pyramid construction achievements. Egyptian mathematical papyri demonstrate knowledge of geometric principles, while astronomical texts reveal understanding of celestial mechanics sufficient for the precise alignments observed at Giza. The administrative systems documented in contemporary inscriptions show the bureaucratic sophistication necessary to coordinate massive construction projects involving thousands of workers over decades-long time frames. Recent archaeological discoveries continue to support conventional interpretations while providing new insights into ancient Egyptian capabilities and achievements. The discovery of the Wadi al-Jaf papyri has revealed detailed documentation of pyramid construction logistics, including transportation systems, worker organization, and resource management that demonstrates the sophisticated planning and execution capabilities of 4th dynasty administrators. These contemporary records provide direct evidence for the methods and organization used in pyramid construction without requiring appeal to lost civilizations or external technological assistance. The publication of Erich von Daniken's Chariots of the Gods in 1968 fundamentally transformed public discourse surrounding ancient monuments, introducing millions of readers to the provocative hypothesis that extraterrestrial beings visited Earth in antiquity and assisted human civilizations in constructing their most impressive architectural achievements. Von Daniken's analysis of the Great Pyramid focused specifically on the precision of its construction, the mathematical relationships embedded in its dimensions, and the apparent sophistication of engineering techniques that he argued exceeded the documented capabilities of 4th dynasty Egypt. His central premise suggested that ancient Egyptians could not have achieved such remarkable precision without technological assistance from beings possessing advanced knowledge of mathematics, astronomy, and construction engineering. Von Daniken's extraterrestrial intervention theory gained particular traction when examining the transportation and positioning of the massive granite blocks found within the king's chamber, each weighing between 25 and 80 tons and transported from quarries located nearly 900 kilometers away in Aswan. He argued that moving these enormous stones using the ramps, levers, and human labor proposed by conventional archaeology would have required logistical coordination and mechanical capabilities that ancient Egyptians simply did not possess. The precision with which these granite blocks were fitted together, with joints so tight that a knife blade cannot be inserted between them, suggested to von Daniken the use of advanced cutting and lifting technology that could only have originated from extraterrestrial sources. The mathematical precision embedded within the Great Pyramids' dimensions provided additional support for von Daniken's hypothesis, particularly the relationships between the monument's height, base perimeter, and internal chamber proportions that approximate fundamental mathematical constants like pi and the golden ratio. Von Daniken interpreted these mathematical relationships as evidence of advanced knowledge that ancient Egyptians could not have developed independently, arguing that such sophisticated geometric understanding required input from beings with superior scientific and mathematical capabilities. He pointed to the pyramid's base measurement of 230.38 meters and height of 146.59 meters, which create ratios that correspond to Earth's orbital mechanics and dimensional properties in ways that seemed impossibly advanced for Bronze Age civilization. The astronomical alignments discovered throughout the Giza complex provided von Daniken with what he considered the most compelling evidence for extraterrestrial involvement, particularly the precise targeting of specific stars and constellations that held significance in ancient Egyptian religious thought. The southern shaft from the king's chamber points directly toward Orion's belt, with an accuracy that required sophisticated understanding of stellar mechanics and precession cycles, knowledge that von Daniken argued could only have been provided by beings capable of interstellar navigation. The correlation between the three main pyramids and the arrangement of stars in Orion's belt, discovered decades after von Daniken's initial work, seemed to validate his claims about ancient astronomical knowledge that exceeded human capabilities. Von Daniken's interpretation of ancient Egyptian religious texts and artistic representations identified numerous references to sky gods and flying vehicles that he interpreted as descriptions of extraterrestrial visitors and their advanced technology. Hieroglyphic inscriptions describing the pharaoh's journey to join the gods in the sky were reinterpreted as accounts of space travel, while depictions of divine beings with unusual physical characteristics were seen as artistic representations of alien visitors. The recurring imagery of celestial boats and flying discs in Egyptian art provided additional support for von Daniken's theory that ancient Egyptians had direct contact with technologically advanced extraterrestrial beings. The influence of von Daniken's work extended far beyond academic circles, inspiring numerous television documentaries, books, and online communities dedicated to exploring extraterrestrial explanations for ancient monuments. The History Channel's Ancient Aliens series, which premiered in 2009, brought these theories to mainstream television audiences and featured regular segments examining the Great Pyramid through the lens of possible alien intervention. The show's format typically presents conventional archaeological explanations alongside alternative theories, creating the impression of legitimate scientific debate while often lacking the rigorous evidence evaluation required for serious historical analysis. Subsequent researchers building on von Daniken's foundation have developed increasingly elaborate theories about the specific methods and motivations behind alleged extraterrestrial assistance in pyramid construction. Zecharia Sitchin's translations of Sumerian cuneiform tablets led him to propose that beings called the Anunnaki visited Earth approximately 450,000 years ago and genetically modified human beings to serve as a labour force for mining operations. According to Sitchin's interpretation, the Great Pyramids served as a navigation beacon for spacecraft approaching Earth, with its precise positioning and electromagnetic properties functioning as a technological device rather than simply a tomb. The electromagnetic properties of the Great Pyramid have attracted significant attention from researchers investigating possible technological functions that extend beyond burial purposes. The pyramid's construction using limestone and granite creates different electrical conductivity zones that some theorists argue could generate or amplify electromagnetic fields under specific conditions. Christopher Dunn's analysis of the monument's internal structure led him to propose that the pyramid functioned as a massive hydrogen fuel cell, with the king's chamber serving as a reaction chamber, where chemical processes converted water into hydrogen gas that could power advanced technology. Dunn's power plant hypothesis focuses on the specific dimensions and materials used in the king's chamber, arguing that the granite construction and precise measurements were designed to create resonance frequencies that could facilitate chemical reactions and energy generation. His examination of the granite surfaces revealed what he interpreted as evidence of advanced machining techniques, including perfectly parallel surfaces and drill holes with spiral grooves that suggested the use of high-speed rotary equipment with diamond-tipped cutting tools. These machining marks, according to Dunn's analysis, could only have been created using technology far more advanced than the copper tools and manual techniques attributed to ancient Egyptian craftsmen. The acoustic properties discovered within the pyramid's internal chambers have been interpreted by some researchers as evidence of advanced sound technology that could have been used for communication, healing, or energy generation purposes. John Stuart Reid's detailed acoustic analysis revealed that the king's chamber exhibits specific resonance frequencies around 110 Hz that create standing wave patterns throughout the granite structure. These acoustic effects, combined with the chamber's precise dimensions and material properties, suggest to some theorists that the pyramid was designed as a sophisticated acoustic device, capable of generating powerful sound waves for technological purposes. The pyramid power movement, which gained popularity during the 1970s, proposed that pyramid-shaped structures possess inherent energy properties that can preserve organic materials, sharpen razor blades, and promote healing through the concentration of mysterious cosmic forces. Proponents of pyramid power theory argued that the specific angles and proportions of the Great Pyramid create energy fields that affect matter at the molecular level, with the pyramid's shape functioning as a geometric antenna that focuses and amplifies natural energy sources. Experimental claims included the preservation of food items placed inside pyramid-shaped containers, the restoration of dull razor blades left overnight within pyramid structures, and enhanced plant growth in pyramid-shaped greenhouses. Scientific testing of pyramid power claims has consistently failed to demonstrate any measurable effects beyond those attributable to normal environmental factors and experimental bias. Controlled experiments conducted by skeptical researchers have shown that pyramid-shaped containers do not preserve organic materials any better than conventional storage methods, while claims about razor blade sharpening and plant growth enhancement have not been reproducible under controlled laboratory conditions. The apparent effects observed by pyramid power enthusiasts appear to result from selective observation, inadequate experimental controls, and the psychological tendency to perceive meaningful patterns in random events. The mystical energy theories surrounding pyramid construction often incorporate concepts from various New Age belief systems, including ideas about ley lines, earth energy grids, and the channeling of cosmic forces through geometric structures. These theories propose that ancient civilizations possessed knowledge of subtle energy systems that modern science has yet to recognize, enabling them to harness natural forces for construction, healing, and spiritual purposes. The Great Pyramid's location at the intersection of proposed energy lines and its alignment with magnetic north are interpreted as evidence of deliberate positioning to maximize access to these hypothetical energy sources. Recent technological advances in archaeological investigation have provided new methods for exploring the internal structure of the Great Pyramid without causing damage to the ancient monument. Cosmic ray muography, a technique that uses naturally occurring cosmic radiation to create images of internal structures, has revealed the presence of previously unknown voids within the pyramid's masonry. The Scan Pyramids project, launched in 2015, employed multiple non-invasive scanning techniques including infrared thermography, muon tomography, and 3D reconstruction to create detailed maps of the pyramid's internal architecture. The discovery of a large void above the Grand Gallery, announced in 2017, created significant excitement among both mainstream archaeologists and alternative theory proponents. This previously unknown space, measuring approximately 30 meters in length and located above the Grand Gallery's ceiling, represents the first major structural discovery within the Great Pyramid since the 19th century. The void's purpose and contents remain unknown, as accessing it would require drilling through the pyramid's masonry and potentially damaging the monument's structural integrity. Thermal imaging surveys conducted as part of the Scan Pyramids project have identified temperature anomalies within the pyramid's eastern face that suggest the presence of additional internal structures or air gaps. These thermal signatures appear most prominently during sunrise and sunset, when temperature differentials between solid masonry and air spaces create detectable variations in surface temperature. The location of these anomalies corresponds to areas where alternative researchers have long suspected the existence of hidden chambers, or passages based on geometric analysis of the pyramid's internal architecture. Ground-penetrating radar surveys have provided additional evidence for structural anomalies within the Great Pyramid's foundation and lower courses, including what appear to be rectangular voids beneath the monument's base that could represent previously unknown chambers or construction features. These subsurface anomalies have not been definitively identified as artificial structures, as they could result from natural geological formations or construction irregularities rather than deliberately created chambers. However, the geometric regularity and positioning relative to the pyramid's axis suggest the possibility of intentional architectural features. The application of artificial intelligence and machine learning algorithms to analyze the vast amounts of data generated by modern scanning techniques has revealed subtle patterns in the pyramid's construction that were previously undetectable. Computer analysis of muon tomography data has identified density variations within the pyramid's masonry that suggest the presence of additional internal structures or construction techniques that differ from the assumed solid stone construction. These algorithmic discoveries require further investigation to determine whether they represent genuine architectural features or artifacts of the scanning and analysis process. Conspiracy theories about government cover-ups and suppressed archaeological findings at Giza have proliferated alongside technological advances in pyramid research, with some alternative researchers claiming that authorities deliberately conceal discoveries that would challenge conventional historical narratives. These theories typically focus on allegations that the Egyptian Ministry of Tourism and Antiquities restricts access to certain areas of the pyramid complex and suppresses publication of research results that contradict official positions about pyramid construction and dating. Proponents argue that economic interests related to tourism and political concerns about religious sensitivities motivate these alleged cover-ups. The restricted access to certain areas within the Great Pyramid, including the chamber above the King's Chamber and various passages that remain unexplored, has fueled speculation about hidden discoveries that authorities refuse to make public. While these access restrictions exist primarily for conservation purposes and visitor safety, conspiracy theorists interpret them as evidence of deliberate concealment of artifacts or architectural features that would support alternative theories about pyramid construction. The lengthy approval processes required for research permits and the limited number of investigators allowed within the pyramid's internal chambers are seen as additional evidence of systematic suppression of potentially revolutionary discoveries. Claims about suppressed archaeological findings often focus on allegations that excavations at Giza have uncovered artifacts or architectural features that predate the 4th dynasty but have been removed from public view or misrepresented in official reports. These theories typically lack specific evidence or credible documentation, relying instead on anonymous sources and unverified accounts from individuals claiming insider knowledge of archaeological cover-ups. The absence of published evidence for such discoveries is explained by conspiracy theorists as proof of the effectiveness of suppression efforts rather than evidence against the existence of such findings. The role of international archaeological institutions and academic peer review processes in validating pyramid research has become another focus of conspiracy theories, with some alternative researchers claiming that mainstream academia systematically rejects evidence that challenges conventional interpretations. These theories propose that established Egyptologists maintain their professional positions and research funding by adhering to orthodox views about pyramid construction while suppressing or discrediting research that supports alternative explanations. The competitive nature of academic publishing and the conservative tendencies of peer review are interpreted as mechanisms for maintaining intellectual orthodoxy rather than ensuring research quality. Social media platforms and internet communities have amplified conspiracy theories about pyramid research by providing forums where alternative researchers can share their findings without subjecting them to traditional peer review processes. These online communities often develop elaborate theoretical frameworks that incorporate elements from multiple conspiracy theories, creating comprehensive alternative narratives about ancient history that encompass extraterrestrial intervention, lost advanced civilizations, and systematic suppression of archaeological evidence. The echo chamber effect of these online communities reinforces alternative beliefs while isolating participants from mainstream archaeological perspectives and critical evaluation. The commercialization of alternative pyramid theories through books, documentaries, and tourism ventures has created economic incentives for promoting sensational claims about hidden chambers, ancient technology, and government cover-ups. Publishers and media producers recognize that conspiracy theories about ancient monuments attract larger audiences than conventional archaeological content, leading to the proliferation of speculative content that prioritizes entertainment value over scholarly rigor. This commercial dynamic has contributed to the persistence and evolution of pyramid conspiracy theories, despite the lack of credible supporting evidence. The psychological appeal of conspiracy theories about the Great Pyramid reflects broader human tendencies to seek simple explanations for complex phenomena and to attribute extraordinary achievements to mysterious or supernatural causes. The monument's undeniable impressiveness and the technical challenges involved in its construction create cognitive dissonance for observers who struggle to reconcile ancient Egyptian capabilities with the evident sophistication of pyramid engineering. Conspiracy theories resolve this dissonance by proposing external explanations that preserve the monument's mysterious character while avoiding the need to understand complex historical and technological processes. Modern pyramid research continues to reveal new information about ancient Egyptian construction techniques, organizational systems, and technological capabilities through rigorous archaeological investigation and scientific analysis. The discovery of workers' villages, harbour installations, and administrative papyri has provided detailed insights into the methods and organization used in pyramid construction, demonstrating that 4th dynasty Egyptians possessed the knowledge, resources, and social systems necessary for these remarkable achievements. These discoveries support conventional archaeological interpretations while undermining the premises underlying most conspiracy theories about pyramid construction. The ongoing tension between mainstream archaeology and alternative pyramid theories reflects broader conflicts between scientific methodology and speculative interpretation in understanding ancient history. While conspiracy theories about aliens, energy devices, and hidden chambers continue to attract popular attention, the accumulated evidence from decades of careful archaeological investigation consistently supports conventional explanations for pyramid construction that credit ancient Egyptian civilization with remarkable but entirely human achievements in engineering, mathematics, and social organization. The integration of cutting-edge scientific technology with archaeological investigation has revolutionized our understanding of the Giza pyramid complex, revealing hidden structures and construction details that remained invisible to researchers for over 4 millennia. Ground-penetrating radar systems, first deployed at Giza during the 1980s, utilize electromagnetic pulses transmitted into the ground to detect subsurface anomalies, density variations, and structural features that suggest the presence of previously unknown chambers or architectural elements. These radar surveys have identified numerous subsurface irregularities beneath the Great Pyramid's foundation, including what appear to be rectangular voids measuring several meters in length that could represent construction chambers, storage areas, or deliberate architectural features integrated into the monument's design. The application of cosmic ray muography to pyramid research represents one of the most significant technological advances in archaeological investigation, employing naturally occurring muons, high-energy particles created when cosmic rays interact with Earth's atmosphere, to create detailed images of internal structures without causing any damage to ancient monuments. Muons possess the unique ability to penetrate dense materials like stone, while being absorbed at different rates depending on material density, allowing researchers to map internal voids, passages, and density variations with remarkable precision. The technique functions similarly to medical X-ray imaging but uses cosmic radiation instead of artificially generated electromagnetic waves, making it completely non-invasive and suitable for investigating culturally sensitive archaeological sites. The Scan Pyramids project, launched in 2015 through collaboration between Egyptian authorities and international research teams, deployed multiple muon detection systems around the Great Pyramid to create comprehensive three-dimensional maps of its internal structure. These detectors, positioned at various angles around the monument's base, recorded muon trajectories over periods of several months to accumulate sufficient data for accurate imaging. The resulting muographic images revealed density variations within the pyramid's masonry that correspond to known chambers and passages while also identifying previously unknown structural features that require further investigation. The most significant discovery emerging from muographic analysis was announced in November 2017, when researchers confirmed the existence of a large void located above the Grand Gallery and measuring approximately 30 meters in length with cross-sectional dimensions similar to the Grand Gallery itself. This previously unknown space, designated as the Big Void by the research team, represents the first major structural discovery within the Great Pyramid since the 19th century explorations that identified the existing chamber system. The void's position directly above the Grand Gallery suggests it may have served a structural function related to weight distribution, though its precise purpose and potential contents remain subjects of ongoing investigation. Thermal infrared imaging has provided another powerful tool for investigating pyramid construction, detecting temperature variations across stone surfaces that reveal internal structural features, construction joints, and material composition differences. These thermal surveys, conducted during specific times of day when temperature differentials are most pronounced, have identified anomalous heating and cooling patterns on the Great Pyramid's eastern face that suggest the presence of internal air gaps or different construction materials. The thermal signatures appear most clearly during sunrise and sunset periods, when solar heating creates maximum temperature contrast between solid masonry and void spaces, Advanced 3D laser scanning technology has enabled researchers to create incredibly detailed digital models of pyramid surfaces with millimeter-level accuracy, documenting construction techniques, tool marks, and weathering patterns that provide insights into ancient building methods. These high-resolution scans reveal the precise fitting of individual stone blocks, the methods used to achieve smooth surfaces, and evidence of the tools employed during construction. The laser scanning data has also enabled virtual arid reconstruction of damaged or missing architectural elements, including theoretical models of the Great Pyramids' original smooth limestone casing and missing capstone, photogrammetry techniques, which create detailed three-dimensional models from overlapping photographs taken from multiple angles, have been extensively applied to document the internal chambers and passages of the Great Pyramid. These photogrammetric surveys have produced virtual reality models that allow researchers to study architectural details, measure precise dimensions, and identify construction features that are difficult to observe during brief visits to the monument's interior. The resulting digital archives preserve detailed records of the pyramid's current condition, while providing baseline data for monitoring future changes caused by environmental factors or structural settling. Robotic exploration systems have enabled investigation of areas within the pyramid that are inaccessible to human researchers, including the narrow shafts extending from the Queen's Chamber that terminate within the monument's masonry. Rudolf Gantenbrink's pioneering robot explorations during the 1990s revealed the presence of copper fittings and stone blocks within these passages, leading to speculation about their function and the possibility that they contain mechanical devices or symbolic elements related to ancient Egyptian religious beliefs. Subsequent robotic missions have provided increasingly detailed documentation of these mysterious passages while raising new questions about their construction and purpose. The National Geographic Society's exploration of the southern shaft from the Queen's Chamber in 2002 employed a more sophisticated robot equipped with drilling capabilities and fibre-optic cameras to penetrate beyond the stone block discovered by Gantenbrink's earlier mission. This investigation revealed the presence of a small chamber behind the block, containing what appeared to be rough stone walls with no obvious artifacts or decorative elements. The discovery of this previously unknown space demonstrated the potential for robotic exploration to reveal additional architectural features, while highlighting the complexity of the pyramid's internal structure. Materials analysis techniques have provided crucial insights into the sources of stones used in pyramid construction, the methods employed to transport and shape these materials, and the environmental conditions that have affected the monument over millennia. X-ray fluorescence spectroscopy and other analytical methods have confirmed that the limestone blocks forming the pyramid's core originated from local Giza quarries, while the fine white limestone used for casing stones came from the Tura quarries located approximately 13 kilometers south of the construction site. Granite elements within the King's Chamber have been definitively linked to the Aswan quarries nearly 900 kilometers to the south, confirming ancient accounts of long-distance stone transportation. Petrographic analysis of limestone samples has revealed detailed information about the geological formation from which pyramid stones were extracted, including the presence of specific fossil species that serve as geological markers for particular quarry locations. These microscopic examinations have identified the precise stratigraphic layers from which different blocks were removed, providing insights into ancient quarrying techniques and the systematic extraction methods employed to obtain stones with consistent properties. The analysis has also revealed evidence of ancient tool marks and extraction techniques that demonstrate sophisticated understanding of stone fracture patterns and controlled breaking methods. Radiocarbon dating of organic materials found within the pyramid's mortar joints has provided independent confirmation of the monument's 4th dynasty construction date, with samples consistently yielding dates between 2600 and 2500 BC that correspond to the reign of Khufu. These dating results have been obtained from charcoal fragments, reed fibers, and other organic materials that were incorporated into the mortar during construction, providing direct evidence for the pyramid's age that is independent of historical records or stylistic analysis. The consistency of these radiocarbon dates across multiple samples and locations within the pyramid strongly supports conventional chronological interpretations. Optically stimulated luminescence dating of quartz grains within pyramid mortar has provided additional chronological evidence that confirms the 4th dynasty construction period. This technique measures the time elapsed since quartz crystals were last exposed to sunlight, providing dates for when mortar materials were mixed and applied during construction. The luminescence dates obtained from Great Pyramid samples consistently fall within the expected range for 4th dynasty construction, providing independent corroboration of radiocarbon dating results and historical chronologies. Environmental monitoring systems installed throughout the Great Pyramid have revealed the complex microclimate conditions that affect the monument's preservation, including temperature fluctuations, humidity levels, air circulation patterns, and chemical processes that contribute to stone deterioration. These monitoring systems have identified specific areas where environmental conditions pose particular threats to structural stability, including zones where salt crystallization causes stone expansion and cracking. The data collected has informed conservation strategies designed to minimize environmental damage while maintaining public access to the monument's interior. Air quality measurements within the pyramid's chambers have revealed elevated levels of carbon dioxide, humidity, and airborne particles that result from visitor traffic and limited ventilation. These conditions create preservation challenges, while also affecting the health and safety of tourists and researchers working within the confined spaces. The installation of improved ventilation systems and visitor management protocols has helped address these issues while providing valuable data about air circulation patterns within the monument's complex internal structure. The phenomenon of salt efflorescence on interior stone surfaces has been extensively studied through chemical analysis and environmental monitoring, revealing the processes by which groundwater carries dissolved salts into the pyramid's masonry, where they crystallize and cause structural damage. These studies have identified the sources of salt contamination and the environmental conditions that promote crystallization, leading to the development of conservation treatments designed to remove existing salt deposits and prevent future accumulation. The research has also revealed the historical timeline of salt damage, with some areas showing evidence of crystallization processes that began shortly after the pyramid's construction. Structural engineering analysis using modern computational methods has provided new insights into the loads and stresses acting on the Great Pyramid's internal chambers and passages, revealing the sophisticated understanding of structural mechanics that ancient builders possessed. Finite element analysis of the King's Chamber's relieving chamber system has demonstrated how the 5 granite layers above the burial chamber effectively distribute the enormous weight of overlying masonry while preventing structural failure. These calculations confirm that the ancient architects possessed practical knowledge of load distribution and stress concentration that enabled them to create stable internal spaces within a monument containing over 6 million tons of stone. The analysis of construction joint patterns and block placement sequences has revealed the systematic building methods employed during pyramid construction, including evidence for the use of temporary ramps, lifting devices, and construction platforms that enabled workers to position massive blocks with precision. Digital modelling of construction sequences has demonstrated how ancient builders coordinated the placement of internal architectural elements with the progressive construction of the pyramid's external structure, requiring sophisticated project management and engineering planning. Acoustic analysis of the pyramid's internal spaces has revealed complex sound transmission properties that may have held religious or practical significance for ancient Egyptians. The King's Chamber exhibits strong resonance at frequencies around 110 Hz, creating standing wave patterns that would amplify human voices and musical instruments used during burial ceremonies. The Grand Gallery's corbelled construction creates unique acoustic effects that channel and modify sound transmission between different levels of the monument, suggesting that the ancient architects deliberately designed these spaces to enhance ceremonial activities. Electromagnetic surveys have mapped the electrical properties of pyramid masonry, revealing variations in conductivity that correspond to different stone types, moisture content, and structural features. These measurements have identified areas where groundwater infiltration affects stone stability and have provided insights into the electrical properties that some alternative researchers claim demonstrate technological functions. However, scientific analysis has shown that the electromagnetic characteristics result from natural geological and environmental factors rather than deliberate technological design. Ground-penetrating radar surveys of the area surrounding the Great Pyramid have identified numerous subsurface features that may represent previously unknown architectural elements, including what appear to be foundation structures, drainage systems, and possibly additional chambers or passages extending beyond the monument's visible boundaries. These discoveries have expanded understanding of the pyramid complex's full extent while revealing the sophisticated infrastructure that supported construction and ceremonial activities. The radar data has also identified areas where future excavation might reveal additional information about ancient building techniques and site organization. The application of machine learning algorithms to analyze the vast data sets generated by modern scanning techniques has revealed subtle patterns in pyramid construction that were previously undetectable through conventional analysis methods. Artificial intelligence systems have identified correlations between different types of structural data that suggest previously unknown construction techniques or architectural features that require further investigation. These computational approaches have the potential to reveal additional insights as scanning technologies continue to improve and generate increasingly detailed data sets. Recent advances in non-destructive testing methods have enabled researchers to assess the structural condition of pyramid masonry without causing damage to the ancient monument. Ultrasonic testing reveals internal cracks and voids within individual stone blocks, while impact echo techniques identify areas where mortar joints have deteriorated or where structural elements have become detached. These assessment methods provide crucial information for conservation planning while contributing to understanding of how the pyramid structure has changed over millennia of environmental exposure. The challenge of preserving the Great Pyramid for future generations has become increasingly urgent as environmental factors, tourism pressures, and urban development threaten the monument's long-term stability. Air pollution from nearby Cairo creates acid rain conditions that accelerate limestone dissolution, while groundwater contamination from urban sources introduces chemicals that promote salt crystallization and stone deterioration. Rising groundwater levels, caused by changes in Nile River management and urban water systems, have altered the moisture conditions around the pyramid's foundation and contributed to structural problems that require ongoing monitoring and intervention. Tourism management represents one of the most significant contemporary challenges facing the Giza complex, with millions of annual visitors creating environmental pressures that threaten the monument's preservation while generating essential revenue for conservation efforts. The installation of visitor management systems, including timed entry protocols and environmental monitoring, has helped balance preservation needs with public access requirements. However, the long-term sustainability of current visitation levels remains questionable given the cumulative effects of human presence on the pyramid's delicate internal environment. Climate change impacts on the Giza Plateau include increasing temperatures, changing precipitation patterns, and more frequent extreme weather events that accelerate weathering processes and create new preservation challenges. The expansion and contraction of stone materials due to temperature fluctuations causes microfracturing that weakens structural integrity over time, while occasional heavy rainfall events create flooding conditions that the ancient drainage systems cannot adequately manage. These environmental changes require adaptive conservation strategies that account for evolving conditions while maintaining the monument's historical integrity. Urban encroachment around the Giza Plateau has created pollution sources, altered drainage patterns, and introduced vibrations from construction activities that potentially affect pyramid stability. The expansion of Greater Cairo has brought industrial facilities, transportation infrastructure, and residential developments close to the ancient monuments, creating environmental conditions that differ significantly from those that existed during most of the pyramid's history. Managing these urban impacts requires coordination between archaeological authorities, urban planners, and environmental regulators to ensure that modern development does not compromise ancient monuments. The development of new conservation materials and techniques specifically designed for limestone monument preservation has provided tools for addressing deterioration while maintaining historical authenticity. These include consolidation treatments that strengthen weakened stone, protective coatings that reduce environmental damage, and repair materials that match the properties of original construction materials. However, the application of any conservation treatment to monuments of such historical significance requires extensive testing and careful consideration of long-term effects. International collaboration in pyramid research and conservation has brought together expertise from multiple disciplines and institutions to address the complex challenges facing these ancient monuments. The Scan Pyramids project exemplifies this collaborative approach, combining Egyptian archaeological expertise with international technological capabilities to advance understanding while respecting cultural heritage values. Such partnerships provide models for future research initiatives that can leverage global resources while ensuring that investigations serve the interests of heritage preservation and scientific knowledge advancement. The ancient Greeks encountered the Giza pyramids as monuments already steeped in mystery and antiquity, their original builders separated from Herodotus by nearly 2 millennia when the historian visited Egypt around 450 BC. Greek interpretations of these colossal structures reflected their own cultural values and philosophical frameworks, transforming the pyramids from royal tombs into symbols of human ambition, divine power, and architectural wonder that would influence Western thought for centuries. Herodotus recorded detailed accounts of pyramid construction based on conversations with Egyptian priests, describing elaborate systems of ramps, pulleys, and organized labor that involved over 100,000 workers, laboring for 20 years under Khufu's reign. The Greek fascination with pyramid geometry and mathematical relationships established patterns of interpretation that emphasized the monument's intellectual achievements alongside their physical grandeur. Mathematicians like Thales and later scholars measured pyramid dimensions with increasing precision, discovering relationships between height, base length, and angular measurements that seemed to encode fundamental mathematical principles. These geometric investigations transformed the pyramids into symbols of ancient wisdom and mathematical sophistication, establishing a tradition of seeking hidden knowledge within their proportions that would persist through subsequent centuries. Greek historical accounts, particularly those of Diodorus Siculus writing in the 1st century BC, portrayed the pyramids as monuments to royal vanity and oppression, emphasizing the human cost of their construction while marveling at their technical achievement. Diodorus described Khufu as a tyrannical ruler who closed temples, forced citizens into labor gangs, and bankrupted Egypt to satisfy his megalomaniacal desires for eternal commemoration. These interpretations reflected Greek political values that celebrated democratic governance while condemning autocratic excess, casting the pyramids as cautionary tales about unchecked royal power. The Roman conquest of Egypt in 30 BC brought new perspectives to pyramid interpretation, with Roman writers and administrators viewing these monuments through the lens of imperial administration and engineering prowess. Pliny the Elder's natural history provided detailed descriptions of pyramid construction techniques, emphasizing the logistical challenges of quarrying, transporting, and positioning massive stone blocks across vast distances. Roman accounts focus particularly on the organizational systems required to coordinate such massive projects, seeing parallels between pyramid construction and contemporary Roman engineering achievements like aqueducts, amphitheatres, and road networks. Roman tourism to the Giza complex established patterns of visitor behaviour and cultural interpretation that would influence subsequent centuries of pyramid exploration. Wealthy Romans travelled to Egypt specifically to view the pyramids, often leaving graffiti inscriptions that recorded their visits and impressions. These tourist inscriptions, carved into pyramid stones and nearby monuments, provide evidence of how educated Romans understood and responded to these ancient structures. The inscriptions typically emphasize the monument's age, scale, and mysterious construction methods, reflecting Roman appreciation for engineering achievement combined with romantic fascination with exotic antiquity. The rise of Christianity fundamentally altered European interpretations of the pyramids, with early Christian writers struggling to reconcile these impressive pagan monuments with biblical chronology and theological frameworks. Some Christian scholars identified the pyramids as granaries built by Joseph during the 7 years of plenty described in Genesis, transforming them from pagan tombs into instruments of divine providence that saved Egypt from famine. This interpretation, popularized by writers like Julius Honorius in the 4th century AD, provided a biblically acceptable explanation for the pyramids' existence while acknowledging their impressive scale and construction quality. Medieval European knowledge of the pyramids came primarily through Islamic sources, as direct European access to Egypt remained limited during the centuries following the Arab conquest in 641 AD. Islamic scholars and travellers provided detailed accounts of pyramid exploration, including descriptions of internal chambers, passages and artefacts that had been discovered through systematic investigation. These Arabic texts, later translated into Latin, form the primary source of European pyramid knowledge throughout the medieval period, influencing scholarly understanding and popular imagination about these mysterious monuments. The Islamic Golden Age produced sophisticated analyses of pyramid construction and purpose that combined empirical observation with mathematical investigation and historical research. Scholars like Al-Makrizi in the 15th century conducted detailed surveys of the Giza complex, measuring dimensions, documenting internal features, and recording local traditions about the monument's origins and significance. These Islamic investigations emphasize the pyramid's mathematical precision and astronomical alignments, interpreting them as products of advanced ancient knowledge rather than mere royal vanity or biblical necessity. Medieval Islamic accounts describe systematic exploration of pyramid interiors, including the discovery of chambers, passages, and artifacts that revealed sophisticated construction techniques and possible ritual purposes. Al-Mamun's 9th century expedition to penetrate the Great Pyramid resulted in the discovery of the ascending passage and upper chamber system, providing the first detailed documentation of the monument's complex internal architecture. These explorations were motivated by rumours of treasure and ancient knowledge, reflecting Islamic scholarly interest in preserving and understanding pre-Islamic learning and technology. The mathematical investigations conducted by medieval Islamic scholars established precise measurements of pyramid dimensions and identified geometric relationships that would later influence European Renaissance thinking about ancient wisdom and hidden knowledge. Scholars calculated pyramid volumes, surface areas, and angular measurements with remarkable accuracy, creating detailed architectural drawings that preserved information about construction techniques and design principles. These mathematical studies emphasized the intellectual achievements of pyramid builders, while speculating about the astronomical knowledge and engineering capabilities required for such precise construction. Islamic interpretations of pyramid symbolism drew on both ancient Egyptian sources and contemporary theological frameworks, seeing these monuments as examples of human achievement constrained by divine will and the inevitability of death. Islamic scholars recognize the pyramids' function as royal tombs, while appreciating their technological sophistication, interpreting them as demonstrations of worldly power ultimately subject to divine judgment. This perspective influenced later European thinking about the relationship between human ambition and divine authority, contributing to romantic and philosophical interpretations of ancient monuments. The European Renaissance marked a fundamental transformation in pyramid interpretation, as renewed interest in classical learning and empirical investigation brought new approaches to understanding these ancient monuments. Renaissance scholars gained access to previously unknown Greek and Arabic texts about the pyramids, while developing new mathematical and astronomical tools for analysing their construction and significance. The printing press enabled widespread distribution of pyramid descriptions and illustrations, making these monuments accessible to educated audiences across Europe and stimulating popular interest in ancient Egyptian civilization. Renaissance mathematical investigations of pyramid geometry built on medieval Islamic scholarship, while introducing new analytical methods derived from advances in algebra, trigonometry, and astronomical calculation. Scholars like John Greaves, who visited Giza in 1638, conducted precise measurements of pyramid dimensions using improved surveying instruments and mathematical techniques. Greaves's work established accurate baseline measurements that enabled subsequent researchers to identify mathematical relationships and construction principles with unprecedented precision. The development of Renaissance architectural theory incorporated pyramid design principles into contemporary building practices, with architects studying ancient Egyptian construction techniques for insights into structural engineering and aesthetic proportion. Leon Battista Alberti and other architectural theorists analyze pyramid geometry to understand principles of stability, proportion, and visual impact that could be applied to modern construction projects. These studies contributed to the development of architectural classicism while establishing the pyramids as exemplars of timeless design principles. Renaissance art and literature increasingly featured pyramid imagery as symbols of ancient wisdom, eternal duration, and mysterious knowledge that connected contemporary European culture with classical antiquity. Artists incorporated pyramid motifs into paintings, sculptures, and decorative arts, while writers used pyramid symbolism to explore themes of mortality, achievement, and the relationship between human ambition and divine will. These artistic interpretations established visual and literary conventions that would influence European culture for centuries. The Age of Enlightenment brought systematic scientific investigation to pyramid studies, with scholars applying empirical methods and rational analysis to questions about construction techniques, historical chronology, and cultural significance. Enlightenment thinkers approached the pyramids as subjects for scientific investigation, rather than objects of religious or mystical speculation, emphasizing the importance of direct observation, accurate measurement, and logical reasoning in understanding ancient monuments. This scientific approach established methodological foundations that would guide subsequent archaeological investigation. The 18th century witnessed the first systematic European expeditions to Egypt specifically focused on documenting and studying ancient monuments, including detailed surveys of the Giza pyramid complex. These expeditions, often organised by European learned societies and funded by wealthy patrons, brought together scholars with diverse expertise in mathematics, astronomy, architecture, and natural philosophy. The expeditions produced detailed drawings, measurements, and written accounts that provided European audiences with unprecedented access to accurate information about pyramid construction and condition. Napoleon's Egyptian campaign of 1798 to 1801 represented a watershed moment in European engagement with ancient Egyptian civilization, bringing together military conquest with scholarly investigation in an unprecedented combination of imperial expansion and scientific research. The expedition included over 160 scholars, artists and scientists tasked with documenting Egyptian monuments, culture and natural resources while supporting French military objectives. The scholarly results of Napoleon's expedition, published in the monumental Description de l'Égypte, provided European audiences with the most comprehensive and accurate documentation of Egyptian antiquities ever produced. The scientific investigations conducted during Napoleon's expedition established new standards for archaeological documentation and analysis, employing systematic measurement techniques, detailed artistic reproduction, and comparative analysis across multiple sites and monuments. Scholars measured pyramid dimensions with unprecedented precision, documented internal chamber systems through detailed drawings and descriptions, and analysed construction techniques through careful observation of stone-cutting methods, joint patterns, and structural engineering solutions. These investigations provided the empirical foundation for subsequent Egyptological research, while demonstrating the potential of scientific methods for understanding ancient civilizations. The discovery of the Rosetta Stone during Napoleon's expedition revolutionized European understanding of ancient Egyptian civilization by providing the key to deciphering hieroglyphic writing systems. Jean-François Champollion's successful decipherment of hieroglyphics in 1822 opened vast archives of ancient Egyptian texts that revealed detailed information about pyramid construction, religious beliefs, and historical chronology. The ability to read ancient Egyptian sources transformed pyramid studies from speculative interpretation to historically grounded analysis based on contemporary documentary evidence. The birth of modern Egyptology during the early 19th century established institutional frameworks and methodological approaches that would guide pyramid research for subsequent generations. European museums, universities, and learned societies created positions for Egyptian specialists while funding expeditions and research projects focused on systematic documentation and analysis of ancient monuments. These institutional developments provided stable support for long-term research programs while establishing professional standards for archaeological investigation and scholarly publication. The work of early Egyptologists like Giovanni Battista Belzoni, Auguste Mariette, and Flinders Petrie established methodological foundations for pyramid research that emphasized careful documentation, precise measurement, and systematic analysis of construction techniques and historical context. Belzoni's dramatic discoveries within Egyptian tombs and temples captured public imagination while demonstrating the potential for systematic exploration to reveal previously unknown aspects of ancient Egyptian civilization. Mariette's establishment of the Egyptian Antiquities Service created institutional frameworks for protecting and studying Egyptian monuments while regulating foreign archaeological activities. Flinders Petrie's meticulous surveys of the Great Pyramid between 1880 and 1882 set new standards for archaeological precision and scientific rigour, producing measurements accurate to within millimetres and detailed analyses of construction techniques that remain valuable to contemporary researchers. Petrie's work demonstrated the importance of systematic measurement and careful observation in understanding ancient construction methods while establishing methodological approaches that would influence subsequent generations of archaeologists. His detailed publications provided comprehensive documentation of pyramid architecture while analysing construction sequences and engineering solutions with unprecedented precision. The development of photography during the mid-19th century revolutionised pyramid documentation by providing accurate visual records that complemented written descriptions and architectural drawings. Early photographers like Maxime Ducamp and Francis Frith created systematic photographic surveys of Egyptian monuments that captured construction details, weathering patterns, and spatial relationships with unprecedented accuracy. These photographic archives provided researchers with permanent visual records while making Egyptian monuments accessible to audiences who could never visit Egypt in person. The influence of pyramid imagery on 19th century European and American culture extended far beyond scholarly circles, permeating popular literature, art, architecture, and decorative arts in ways that reflected contemporary fascination with ancient wisdom and exotic antiquity. Romantic writers like Percy Bysshe Shelley and Lord Byron incorporated pyramid symbolism into poetry that explored themes of temporal permanence, human ambition, and the relationship between civilization and nature. These literary works established cultural associations between pyramids and philosophical reflection on mortality, achievement, and the passage of time. Victorian architecture incorporated pyramid motifs and Egyptian design elements into buildings ranging from cemetery monuments to public institutions, reflecting popular fascination with ancient Egyptian aesthetics and symbolism. The construction of pyramid-shaped mausoleums, Egyptian revival buildings, and decorative objects featuring pyramid imagery demonstrated the extent to which these ancient monuments had penetrated contemporary visual culture. These architectural borrowings often combined Egyptian motifs with contemporary construction techniques and materials, creating hybrid styles that reflected 19th century interpretations of ancient design principles. The emergence of popular literature focused on pyramid mysteries and ancient secrets established narrative conventions that would influence subsequent fictional treatments of these monuments. Novels, short stories, and sensational journalism featured pyramids as settings for adventure, discovery, and encounters with supernatural forces, creating literary traditions that emphasize the monument's mysterious qualities while often ignoring their historical and cultural contexts. These popular treatments contributed to public fascination with pyramids, while sometimes promoting misconceptions about their construction and purpose. The development of tourism to Egypt during the 19th century transformed the pyramids from remote archaeological sites into accessible destinations for wealthy European and American travelers seeking encounters with ancient civilization. Thomas Cook's organized tours to Egypt, beginning in the 1860s, made pyramid visits routine components of grand tour itineraries, while establishing commercial frameworks for managing tourist access to archaeological sites. These tourism developments created economic incentives for monument preservation, while generating new forms of cultural interpretation focused on visitor experience rather than scholarly analysis. The rise of spiritualism and occult movements during the late 19th and early 20th centuries created new interpretive frameworks that portrayed the pyramids as repositories of ancient wisdom and supernatural power. Theosophical writers like Helena Blavatsky incorporated pyramid symbolism into elaborate cosmological systems that claimed to reveal hidden truths about human spiritual evolution and cosmic consciousness. These esoteric interpretations often drew on genuine archaeological discoveries, while embedding them within speculative philosophical and religious frameworks that emphasized mystical rather than historical understanding. The influence of pyramid imagery on modern art movements reflected broader cultural fascination with primitive and ancient forms that challenged contemporary aesthetic conventions. Artists associated with movements like Art Deco, Surrealism, and Modernism incorporated pyramid motifs into works that explored relationships between ancient and modern, primitive and sophisticated, mysterious and rational. These artistic treatments often emphasized the pyramid's geometric purity and monumental scale, while interpreting them as symbols of human creativity, transcending historical and cultural boundaries. The development of mass media during the 20th century created new opportunities for pyramid interpretation and cultural influence, with radio programs, films, and television documentaries bringing these monuments to global audiences while shaping popular understanding of their significance. Hollywood films featuring pyramid settings established visual conventions and narrative frameworks that often prioritize dramatic effect over historical accuracy, contributing to popular misconceptions while maintaining cultural fascination with ancient Egyptian civilization. These media treatments created shared cultural references that influenced how contemporary audiences understand and interpret pyramid imagery. The accumulated archaeological and historical evidence regarding the Great Pyramid of Giza presents a remarkably coherent picture of 4th dynasty Egyptian achievement that stands in stark contrast to the sensational theories that have proliferated in popular culture. After more than 2 centuries of systematic investigation, the fundamental questions about pyramid construction, dating, and purpose have been answered through rigorous scientific methodology that combines documentary evidence, archaeological excavation, materials analysis, and technological innovation. The Great Pyramid was built during the reign of Khufu between approximately 2589 and 2566 BC, constructed by organized teams of skilled workers and seasonal laborers using sophisticated but entirely comprehensible ancient Egyptian engineering techniques. The documentary evidence supporting conventional interpretations includes contemporary hieroglyphic inscriptions found within the pyramid's internal chambers, administrative papyri discovered at Wadi al-Jarf that detail construction logistics, and numerous references in later Egyptian texts that identify Khufu as the pyramid's builder. The red ochre inscriptions discovered by Colonel Howard Vyse in 1837 within the relieving chambers above the king's chamber bear Khufu's cartouche, and references to work gangs with names like Friends of Khufu and the White Crown of Khnum Khufu is powerful. These inscriptions, painted by ancient construction crews in areas never intended for public viewing, provide unambiguous evidence linking the pyramid to Khufu's reign, while demonstrating the organised labour system that accomplished this monumental project. The Wadi al-Jarf papyri, discovered by French archaeologist Pierre Tallet in 2013, represent the oldest papyrus documents ever found and provide unprecedented insights into pyramid construction logistics during Khufu's final years. These administrative records detail the transportation of limestone blocks from the Tura quarries to Giza, describing boat crews, delivery schedules, and the harbour installations that connected the Nile to the construction site. Inspector Mera's logbook records daily activities involved in pyramid construction, including specific references to the horizon of Khufu and detailed accounts of stone transportation that demonstrate the sophisticated organisational systems supporting this massive undertaking. Archaeological excavation around the Great Pyramid has revealed extensive infrastructure that supported construction activities, including workers' villages, harbour installations, bakeries, breweries, and administrative buildings that housed and fed the workforce. Mark Lehner's excavations south of the Sphinx have uncovered residential quarters that accommodated thousands of workers, complete with sleeping areas, food preparation facilities, and administrative offices. The workers' cemetery, excavated by Zahi Hawass, contains over 600 burials that provide direct evidence about the lives and working conditions of pyramid builders, revealing adequate nutrition, medical care, and respectful burial practices that contradict popular misconceptions about slave labour. The skeletal remains of pyramid workers show clear evidence of heavy physical labour, including enlarged muscle attachment points, joint degeneration, and healed fractures consistent with construction activities. However, these same remains also demonstrate medical treatment, adequate nutrition, and life expectancies comparable to other segments of ancient Egyptian society. The presence of expensive burial goods, elaborate tomb construction, and respectful treatment of workers' remains indicates that pyramid builders held respected positions within Egyptian society, rather than serving as oppressed slaves forced into labour through coercion. Materials analysis has provided definitive evidence for the sources of stones used in pyramid construction and the methods employed to extract, transport, and shape these materials. Petrographic analysis of limestone samples has confirmed that core blocks originated from local Giza quarries, while the fine white limestone used for casing stones came from Tura quarries located 13 kilometres south of the construction site. Granite elements within the King's Chamber have been linked through geological analysis to the Aswan quarries 900 kilometres to the south, confirming ancient accounts of long-distance stone transportation using Nile barges during flood seasons. Radiocarbon dating of organic materials found within pyramid mortar has consistently yielded dates between 2600 and 2500 BC, providing independent confirmation of 4th dynasty construction that aligns with historical chronologies and archaeological evidence. These dates have been obtained from charcoal fragments, reed fibres, and other organic materials incorporated into mortar during construction, creating a robust chronological framework that supports conventional dating. The consistency of radiocarbon results across multiple samples and locations within the pyramid eliminates the possibility of later construction or significant chronological revision. The engineering techniques documented through archaeological investigation demonstrate that 4th dynasty Egyptians possessed the knowledge, tools, and organizational capabilities necessary for pyramid construction without requiring external assistance or lost advanced technology. Experimental archaeology conducted by researchers like Mark Lehner has demonstrated that teams of 20 to 30 workers could transport 2.5-ton limestone blocks using wooden rollers, rope harnesses, and coordinated pulling techniques. The construction of experimental ramps has shown that earthen and stone ramps could provide access to pyramid heights while maintaining workable gradients for dragging heavy blocks. Tool marks found on pyramid stones reveal the use of copper chisels, wooden mallets, and abrasive materials for shaping and finishing work, consistent with the technological capabilities documented for 4th dynasty Egypt. The precision achieved in stone cutting and fitting resulted from skilled craftsmanship and careful quality control, rather than advanced machinery or supernatural assistance. Experimental stone cutting using replica copper tools has demonstrated that ancient Egyptian techniques could achieve the precision evident in pyramid construction, given sufficient time, skill, and attention to detail. The astronomical alignments incorporated into pyramid design reflect sophisticated understanding of celestial mechanics that developed through centuries of careful observation and mathematical calculation. The Great Pyramid's orientation to cardinal directions with an accuracy of 3 arc minutes and 38 arc seconds could be achieved through systematic observation of circumpolar stars using the stretching of the cord ceremony documented in Egyptian texts. The internal passage alignments targeting specific stars and constellations required precise calculation, but employed astronomical knowledge well within the capabilities of ancient Egyptian priest astronomers. The mathematical relationships discovered in pyramid dimensions, including approximations of pi and the golden ratio, likely resulted from the use of practical measurement systems and construction techniques rather than deliberate incorporation of abstract mathematical constants. The royal cubit measuring system derived from human proportions and astronomical observations naturally generated these mathematical relationships when applied to large-scale construction projects. Recent analysis by mathematician John Legon has demonstrated how Egyptian measurement systems and construction practices would inevitably produce the mathematical relationships observed in pyramid dimensions without requiring theoretical knowledge of irrational numbers. Critical analysis of fringe theories and conspiracy claims reveals fundamental methodological flaws that distinguish legitimate scientific inquiry from unfounded speculation. The ancient astronaut hypothesis proposed by Erich von Daniken lacks any credible physical evidence and relies on the false premise that ancient Egyptians could not have achieved pyramid construction using documented technologies and organizational systems. Von Daniken's interpretations of Egyptian art and texts as evidence of extraterrestrial contact result from selective quotation, cultural misunderstanding, and the imposition of modern technological concepts onto ancient symbolic systems. The geological arguments for pre-dynastic pyramid construction, particularly Robert Schoch's water erosion theory regarding the Sphinx, have been effectively countered by mainstream geologists who identify alternative explanations for observed weathering patterns. The erosion characteristics that Schoch attributes to heavy rainfall can be explained through natural limestone jointing patterns, periodic flooding events, and groundwater seepage that occurred during documented historical periods. The absence of any archaeological evidence for pre-dynastic pyramid construction, combined with extensive documentation of 4th dynasty building activities, undermines theories requiring earlier construction dates. Claims about suppressed archaeological discoveries and government cover-ups lack credible evidence and reflect misunderstanding of archaeological methodology and publication processes. The peer review system that governs academic publishing ensures that significant discoveries receive appropriate scrutiny before publication. While the international nature of Egyptological research makes systematic suppression of evidence practically impossible, the restricted access to certain areas within the Great Pyramid results from conservation concerns and visitor safety requirements, rather than deliberate concealment of revolutionary discoveries. The power plant hypothesis proposed by Christopher Dunn misinterprets normal construction features as evidence of advanced technology while failing to provide credible explanations for how such a device would function or what purpose it would serve. Dunn's identification of machining marks on granite surfaces reflects unfamiliarity with ancient stoneworking techniques rather than evidence of powered machinery. The acoustic properties of pyramid chambers result from architectural design intended to enhance ceremonial activities rather than technological functions related to energy generation or communication. Ongoing research continues to reveal new information about pyramid construction through the application of advanced scientific techniques that complement traditional archaeological methods. The Scan Pyramids project has employed cosmic ray muography, thermal imaging, and 3D reconstruction to identify previously unknown internal structures, including the Big Void discovered above the Grand Gallery in 2017. These investigations demonstrate the potential for non-invasive techniques to reveal additional architectural features while confirming the sophistication of ancient Egyptian engineering. The discovery of the Big Void represents the first major structural finding within the Great Pyramid since the 19th century, measuring approximately 30 meters in length and positioned directly above the Grand Gallery. While the void's purpose and contents remain unknown, its discovery demonstrates that the pyramid may contain additional chambers or structural features that have yet to be explored. The investigation of this void through robotic exploration or other non-invasive methods may provide new insights into pyramid construction techniques and ceremonial functions. Recent archaeological discoveries continue to expand understanding of the social and economic systems that supported pyramid construction. The discovery of additional workers' settlements, harbour installations, and administrative facilities reveals the extensive infrastructure required to sustain construction activities over decades. The identification of specialised workshops for tool production, food processing, and materials preparation demonstrates the complex supply chains and logistical systems that enabled ancient Egyptians to accomplish these massive projects. The true historical significance of the Giza pyramids lies not in mysterious technologies or extraterrestrial assistance, but in their demonstration of human capability, organizational sophistication, and cultural achievement during the early development of complex civilization. The pyramids represent the culmination of centuries of architectural evolution, from simple mastaba tombs through step pyramids to the true pyramids of the 4th dynasty. They demonstrate the ability of ancient societies to mobilize vast resources, coordinate complex projects, and achieve remarkable precision through human skill and determination. The pyramids' enduring legacy reflects their success as monuments to royal power, religious belief, and human ambition that transcended their original cultural context to become symbols of achievement and mystery for subsequent civilizations. Greek and Roman visitors marveled at their scale and precision. Medieval Islamic scholars studied their mathematical properties, and modern researchers continue to discover new aspects of their construction and significance. The pyramids have inspired countless works of art, literature, and popular culture, while serving as touchstones for human understanding of ancient achievement and technological capability. The scientific investigation of the Giza pyramids over the past 2 centuries has revealed them to be even more remarkable than the myths and legends that have surrounded them. Rather than products of lost civilizations or extraterrestrial intervention, they represent the achievements of a sophisticated ancient society that developed advanced engineering techniques, organizational systems, and cultural institutions through human ingenuity and accumulated knowledge. The precision of their construction, the sophistication of their design, and the complexity of their symbolic meaning demonstrate the capabilities of ancient Egyptian civilization, while providing insights into the development of human society during the early Bronze Age. The pyramids stand as permanent testimonies to the power of human cooperation, the importance of cultural continuity, and the ability of organized societies to accomplish seemingly impossible tasks through sustained effort and shared purpose. They remind us that remarkable achievements result from human creativity, determination, and collaborative effort rather than mysterious external assistance or lost technologies. As we continue to study and preserve these monuments, they serve as bridges connecting contemporary civilization with our ancient past while inspiring future generations to pursue their own monumental achievements through knowledge, skill, and collective endeavour. The Great Pyramid of Giza remains what it has always been, the greatest architectural achievement of ancient Egypt, and one of humanity's most remarkable monuments to the power of human imagination, engineering skill, and social organisation. Its mysteries have been largely solved through careful scientific investigation, revealing it to be not less wonderful for being understood, but more remarkable for demonstrating what human beings can accomplish when they combine knowledge, resources, and determination in pursuit of lasting achievement. The pyramid's true significance lies not in the theories it has inspired, but in the reality it represents, a testament to the ingenuity, skill, and ambition of our ancient ancestors who created something so magnificent that it continues to inspire wonder and admiration more than 4 millennia after its completion.